Hello all. So now let us start a new chapter in DBMS, so that is transactions and concurrency control. Okay. So this is also a very interesting topic, and here one transaction how you will perform, and when you have a set of transactions, if you go for the serial transaction, serial execution of these transactions, what are the drawbacks? And if you go for the concurrency, as name implies, concurrence control. So if you execute all the transactions concurrently, what kind of results we will get? And when you are going for the concurrency, what kind of problems you are going to face? So those problems, how you are going to resolve, all these things we are going to discuss in this chapter actually. So first of all, let us try to understand what is transaction. So now let us see the definition of a transaction. So this is very important. Throughout this chapter we are going to refer this meaning actually. So let us try to understand in very simple manner. So first of all, it is a simple collection of operations that performs single logical unit of work actually. So let us try to understand this with a simple understanding. For example, we have a transaction T1. Okay. What is the purpose of this transaction is, assume that there is a person A and there is a person B. So person A want to transfer 100 rupees or $100, simply 100 he want to transfer to B actually. That is what he has to perform. So what are all operations we will perform for this action actually? So that is what actually, first thing is in the transaction, you have to read the balance of A actually first of all. So that is what we are performing, read operation of A. So you got whatever balance we have. Then in A you have to reduce 100 rupees or $100, whatever that currency. Okay. So that is what you are going to reduce 100 from the existing balance. Then after that, whatever remaining amount is there, whatever remaining balance is there, that you have to perform write operation this A actually. So this is what you have to perform for regarding A actually. Then after that, what you have to do, this reduced 100 you have to add to B. So you have to read the balance of B and then add that 100 for B. So B equal to B plus 100, and then this updated value you are going to write back in the memory actually, in the server. So that is write operation of B. So this is after this you are going to commit. So that means the changes you are going to make permanent actually. So this is what one transaction simply you can say. So if you want to transfer 100 rupees from A to B, what are all operations you have to perform? That is what it is, a collection of operations. These are all the operations you are performing. All these are collection of operations. So that performs a single logical unit of work. So this is one logical work which is happening in the system. So that is what actually one transaction, because this transaction word almost in every concept in this chapter we are going to use. So that is why you have to understand very clearly. So that is what the transaction, one transaction meaning is. So here in this case, first you have to read the balance of A. So that is what you are reading. After reading, reduce 100 rupees from A actually. Then write back that result into each server, and then read B balance. For that balance, add this 100 rupees and then write back and make the changes permanent, that is by the commit operation. This whole set of operations we are calling as one transaction. So that is what here, if you see the concurrency control. So like this in real time we are going to have many number of transactions actually at a time. If you go to the bank, so many people at a time they are trying to perform the transactions actually. When all these transactions are happening at a time, how you are maintaining them concurrently? So you just have an idea that what this chapter is going to do. So how these concurrent transactions you are maintaining, without inconsistent data actually. So that is what first of all try to understand what is transaction. Okay.
Hi. So now let us see a very important definitions and which are we are going to discuss continuously in this chapter. So that is first of all schedule, and what is serial schedule and what is concurrent schedule. Okay. So let us try to understand definition wise. So if you see, the first thing is schedule definition. It represents the order in which operations of a transaction are executed. So actually, we already seen that what is a transaction. So when multiple transactions when multiple transactions are there, so in which order these transactions we have to execute actually. So that is what it represents, the order in which the operations of transaction are executed. So when multiple transactions are there, which transaction is first, which transaction is next. So that planning as in general discussion of the schedule meaning is what, that only here also. So that is what a schedule is, the arrangement of transaction operations. That's it, nothing is there. Okay. So you are going to put one after the other in which order you want to execute all transactions actually. So schedule may contain set of transactions, of course. So if one schedule is there, if one transaction is there, you no need to schedule actually, only one that you have to execute as per its operations flow. But when multiple transactions are there, so you must have a plan that in which order you have to execute them. So by considering different parameters actually. So that is what, whatever be the general meaning of the schedule, here also same thing, but for whom you are scheduling, that is for the transactions. That is what you have to understand. So let us try to understand more on this by going into these two different types of schedules. And throughout the course, that means throughout the chapter, we are going to discuss on this only. So the first one is serial schedule. It consists of sequence of instructions from various transactions where instructions belong to each single transaction appears together in the schedule actually. So what does it mean? So for example, schedule S1 I am saying. So if you have a transaction T1 and if you have transaction T2, two transactions are there. So reading A, writing A. So that is what are all operations one transaction you have. Each single transaction appears together. So that means instructions, that is nothing but maybe operations. So that is what read operation, write operation, what are all operations you are going to perform for the T1 all at one place actually. After completion of the one complete transaction, then you are going for the another transaction. That is, for example, here read A, write A you have, for example. So you can see all these operations are together and all the operations of T2 are together. After completion of T1, you are going for T2, or first maybe T2 and then T1 actually. So that is what actually serial schedule. Serial means one after the other completely. So that is what actually meaning of this one. So now if you see the first point from this basic definition, if there are n transactions in a schedule, then the number of possible serial schedules are n factorial. This is like a permutation concept actually. For example, three schedules are there. For example, three transactions are there, A, B, C. So three transactions are there. In which order you are going to execute them? So I'm just explaining these transactions. T1 assume A, T2 assume B, T3 assume C. So if you see three positions, so first may be A, so that second position may be B or C, and third position is C or A. So this is what B. Maybe ABC is one order, ACB is another order. First position may be B and AC, and then here C or A. First position may be C, then A, B. This is normal discussion only, right? Permutations, different possible permutations. So in the first position out of three, you can select any one. So you have three ways actually. In the second position, after selecting one position, you have remaining two elements only. So out of two, anyone you can select two ways and one way. So this is nothing but multiply That is what 3 factorial. So that is what whenever you have a n transactions are there, n factorial schedules are possible actually. That is what ABC one schedule, ACB another schedule, BAC one schedule, BCA one schedule, CAB one schedule, CBA one different schedules actually. So like this T1, T2 or T2, T1. That is what 2 factorial schedules. So this is what actually serial schedules. So whenever we have n transactions, n factorial schedules are possible actually. And one very important thing is, this is what the difference to this serial schedule and for the next what we are going to discuss is, in all n factorial schedules, the database system ensures consistency. Very, very, very important point, this one. Serial schedules are recommended because their solutions are always, their outputs are always consistent. So leaving the database in a consistent state actually, one of the ACID property, that is also you have to ensure. So leaving the database always in the consistent state is the recommended thing, that serial schedules are always guaranteeing that. Okay, but serial schedules, we have a problem actually. So if any smaller transaction is there, before that, if any longer transaction is there, so this smaller transaction is suffering actually, because after completion of the T1, if T1 taking long time and T2 will take very short time, but till T1 is completing, T2 has to wait. And if one transaction actually, as we discussed, CPU and IO, two different missions you can say, which are working parallelly, which can work simultaneously. Suppose T1 transaction is working on CPU, sometimes it may need input IO operation. So when T1 is in IO operation, CPU is idle actually. At that time, CPU is idle. That is what another drawback of the serial schedules. So to overcome all these things, what you are doing is, you are going for concurrent schedules, as name implies actually. So you can see the definition. If two transactions are executing concurrently, then OS may execute one transaction for a little while and then performs the context switch and executes the second transaction for a little while, and so on actually. So this is representing concurrent schedule. Concurrently, progress is going on for the different transactions actually. So that is what, from this example only, if I take one schedule, another schedule, T1 transaction is there, T2 transaction is there. If I take the same operations, for example, you perform the read operation from T1, then that is what he is saying, some operations we performed, and then switching to another transaction, here I performed read operation. So that is what, little while you worked on one transaction and then perform context switch, and second transaction little while we worked, and then I come back to T1 again switched, then little while I am working on T1, and then switch it to T2, little while I am working here. This is what concurrently both of them is progressing actually. So that is the one simple understanding actually. Concurrent schedules means different transactions concurrently they are progressing. That is what actually. Okay. So why we need this kind of situation? Why this is recommended actually? So that is the first one is to minimize the longer waiting times, as I discussed here. If T1 taking longer time than T2, or for example, T2 will take very small time compared to T1. So if you schedule like this, sequential schedule like this, so till T1 is completing, suppose if assume it will take 10 minutes time, assume it will take just 5 seconds. So just 5 seconds transaction has to wait 10 minutes actually. If you compare time wise, how much big difference is there, you can understand. So that is the reason. But now if you schedule like this, then what is happening? Maybe both of them are concurrently progressing. At some point, this much time it need not to wait, right? T2 can complete in between only. So that is what actually longer waiting times you are going to reduce actually. So average response time you can increase actually. Okay, that means you can reduce actually. So response time for every transaction, first execution operation is going to reduce actually. And another very important thing is, as we discussed it here, so we have CPU and IO, input output. So in computer system, it is possible that both CPU and IO operations to be executed simultaneously. That is actually when one transaction is executing CPU operation, the other can execute IO operation actually. So if T1 is at if T1 is performing CPU operation, then T2 may be at IO operation actually. So that both of them is progressing, right? Is it or not? So that is what actually both can work simultaneously. So that means what is happening ultimately? You are efficiently utilizing the CPU and IO resources. Here at any point, only one is working actually because of serial schedule. If T1 is working on CPU, IO is idle. Suppose if any input output is required, then T1 is going to IO. At that time, CPU is idle. So that means you are wasting the resources time actually. But here, because of simultaneous facility you have, that is because of this concurrent schedules. So you are utilizing them efficiently, right? So that is the reason we are moving for the concurrent schedules actually. So that is what actually these two things we are going to refer in the most of the places because our concept itself concurrency control. So of course we have some problems in this concurrent schedule. So those problems we are going to address in the coming lectures, and those problems, how you are addressing them, how you are giving the solutions. So that is what throughout the chapter we are going to discuss actually. Okay. So first of all, this is what the definition of schedule and serial schedule and concurrent schedule.
Hi. So now let us see this question, simple question. So this is actually to make you familiar what we are going to discuss in the next actually. Okay. So that is what just now we seen that concurrent schedules actually, definition wise we seen. So here we are asking to find the number of concurrent schedules are possible with true transactions each with two operations actually. So what does it mean? So here for example, if you take a transaction T1 which is going to have read A actually and write A. And let us take another transaction T2. This is different but same item actually. So read A here also and write A. So whenever you have two transactions each with two operations, that is what two operations we have finally. So ultimately we need only read and write operations only. In between whatever calculations are happening, that is not bothering actually. Ultimately on the database which are affecting either read operation or write operation. So that is why in between all calculations we are going to skip now onwards. Only we will consider read and write operations only. So now let it be. So he is asking that how many concurrent schedules are possible from this actually. So let us see here, if you take the schedule 1, so what we can do? So let us take R1 W1 as a T1 transaction related and R2 W2 as a T2 transaction related. So what we are doing here, R1 of A and then W1 of A, then R2 of A, then W2 of A. So this is one transaction actually, this is one possible schedule. You can schedule like this, these two transactions. And another possible schedule is what? S2 if you take. So then R1 of A, first one you did, and then perform this one actually. So that is what? R2 of A. Then W1 of A, then W2 of A. So that is what? Overall total 4 operations you have to perform, and in the same order you have to perform. So that is what? Here first read operation you have to perform and then write operation. So don't bring W1 first and then R1 next. That is not possible actually. This order you must maintain. So that is why you see R1, after that you have a W1. So this is one possible schedule. So let us take another possible schedule S3. So here R1 of A only, then next R2 of A only, but here W2 of A we are performing, then W1 of A we are performing. So this is what one possible schedule actually. So in these three, if you observe actually, T1 started first, that is what R1, and then of course T2's related operations we have. Then next if you see schedule S4, what we are doing is now we are starting with R2 actually. So just oppositely you can write down different combinations. So R2 of A first, and then W2 of A, then R1 of A, then next one is W1 of A. So then next schedule is S5. So R2 of A first of all, then R1 of A, then W2 of A, W1 of A, and another possibility is R2 of A, R1 of A, and then here W1 of A, then W2 of A. So here if you observe, T2 started first, but of course it is mixed actually. So this is what actually total 6 concurrent schedules are possible actually. So in this if you observe S1 completely T1 related transactions you did, and after that T2 related transactions you did actually. So this is serial schedule, you can say. This is serial schedule, is it? But these are not the serial schedule. S2, S3 is not the serial schedule. And in the same way here, first T2 you did, and then you did T1 actually. So this is also serial schedule. But overall these are the 6 schedules are possible actually if you mix the operations. So this is what total schedules are possible. And serial schedules we are not bothering actually, those are not going to give the good results as we discussed advantages of concurrent schedules actually. Okay. So that is why S2, S3, S5, S6 they may give the better results actually. Okay. But that should they sometimes these concurrent schedules S2, S3, so these things especially may lead to inconsistent data actually. So that also you have to take care. So those things we are going to discuss in the coming lectures. Hi. So now let us see problems due to concurrent schedule actually. So as we discussed in the last lecture, all concurrent schedules are not giving the consistent results actually. So some of the concurrent results, some of the concurrent schedules are going to give the inconsistent data actually. So which is going to lead a problem. So that is why let us try to discuss different problems we are going to have because of this concurrent schedule actually. So in that the first one is last update problem. So this is very simple. Let us try to understand with this schedule actually. This is concurrent schedule, right? Assume this is one schedule, schedule S1. So which is a concurrent schedule. Now, so what is going to happen here is assume that initially A value is 1000. So A value is 1000 initially. Now what is going to happen? If you take this one, if you take this sequence of operations in this manner, so it is reading A value, so it is 1000 it is going to read, fine, and after that A value is going to subtract with 100 actually. So that means now right now A value is 900. So after this what you are doing? You shifted to T2 transaction actually. So that means from T1 to T2 we switched. Now in T2 you are reading the A value. So here A value is 1000. So that is what 1000. Then after that in the next operation what we are doing? We are doing some calculation. So that is what you can see. You are finding the 10% of this 1000. So that we are going to store in X. What is that 10%? That is 100 because this is 0.1 means what actually 10%. Then after that X value you are adding to A. A value is 1000, 1000 plus 100, that is going to become 1100. Now after that we switch it to T1 again. Then we resumed remaining operations. So what is going to happen? A initially 1000, that is what initial value. After that, because of this write operation, what is going to happen? It is writing 900 actually, 900. And after that we came to T2 transaction. So T2 is writing 1100 because A value is 1100 right now. So it is going to become 1100. So if you see which value is correct here. So here either 900 is correct or 1100. So but finally it is 1100. Finally it is 1100. But is it correct value or not? Because here 100 rupees reduced. For example, you are going to withdraw money from the ATM. So 100 rupees you withdrawn. So 900. Upon the 900, you have to calculate 10%. Or before, if you do 10% on 1000, then it is going to become 1100. Upon 1100, if you subtract 100 rupees, then it will become 1000. Either 1000 is correct, or after updating this value, that means 900, on 900 if you calculate 10%, 90 rupees, so 990 it will become. So either 1000 is correct or 990 is correct if you do a sequential schedule actually. But this 1100 is actually a not correct value. Here banker losing the money actually. So that is what actually problem here. This is because of write conflict. So this is also called as write conflict. So WW conflict we can call in short. So that is what the problem here actually. So in this concurrent schedule you have a write conflict, that means inconsistent results we have. So this is the one of the problem you are going to face due to the concurrent schedules actually. So you have to take care this kind of problems should not exist in your concurrent schedule actually. Okay. Hi. So now let us see the next problem, problems due to concurrent schedule actually. So the second one is dirty read problem. So this is also very important one. So that is what you can see here. First of all, the same set of operations for each transaction we taken, but their order is different. That is why this is different schedule. Okay. Okay, fine. So here if you observe, initially as usually A value is 1000 assume. Okay, what is going to happen here? Here you are going to read the A value, so that is 1000 you read, and after that you subtracted 100, so it is going to become 900. Very importantly, you are writing back that result actually. So that means you are updating this A value from 1002 in the database to 900. So now after this operation, A value is 900 in the database. Now if you see after this is still concurrent schedule only because one more operation is there. So that is, and then you are switching to another transaction. So these operations you stopped and switched to another transaction, that is T2. And in T2 what you are doing, you see this is reading the value from A actually, from the database. So what value it is reading? This updated value it is reading, so it is going to become 900. So then this is 900, 900 into 10%, 10% of 900, so that is going to become 90 actually. Then that 90 you are adding to A, so it is going to become 990. Then that you are writing back. So now this is going to become 990 and you are committing, so this is become permanent, and transaction 1 also is going to commit. So this is the final value after these two transactions, that means after this schedule. See, till now there is no problem actually, but when you are going to get a problem is, if at all instead of this commit operation, if something is happened in this transaction, so you decided that you want to roll back all these operations. That means you initially what results are there on the A, that value only you want to set actually. So that means what is going to happen? Here you are going to perform, instead of commit operation, you are going to perform abort operation actually. That meaning is roll back the all operations actually. So that means initial results. So, but now because of this rollback, what is going to happen? Here you committed already actually, and here you are aborted. And what is the problem here is, here you are reading the value which is updated by transaction T1. So then it is leading to a problem actually if it is rollbacked. If it is committed, there is no problem, but you are reading the data, T2 reading the data which is not committed. That is the problem actually. So there is a chance of, if you are reading the not committed data, so there may be a chance of going for rollback. At that time again it will lead to the inconsistent results. So that is the reason this is called dirty read. You are reading, dirty read meaning is what actually? Reading uncommitted data. So that is called dirty read problem. So this is calling as write read conflict actually. So write and then read conflict. So simply you are going for, you are reading the data which is not committed actually. So after this write operation, you are reading that value which is not yet committed. So if at all any abort operation is there, then your entire operations are going to become invalid. It is not only invalid thing, it is making the database inconsistent actually. Okay, so this is what actually dirty read problem. Hi. So now let us see the next problem, that is unrepeatable read problem actually. Okay, so here you can see initially a value as usually assume 1000. Okay, then here you are reading the value. So whenever you are reading first time, a value is 1000. So 1000, okay, fine. And then you are switching to transaction 2, and here we are reading a value that is 1000. Then you are subtracting with 100 actually. So a is going to become 900. Fine. Then you are writing back actually. So that means this value is going to update with 900. Fine. Then you are switching to first transaction. Here if you see, when you are reading same a value again, what you are going to get? 900. So that is what actually unrepeatable read values actually. So between two read operations, if any other transaction perform write operation on the same data item, then you are going to get unrepeatable reads. So which is going to lead to a error actually. So that is also one kind of problem in this concurrence control actually. So in the concurrent schedule, this is also one type of problem. So this problem also we have to address when you are dealing the concurrent schedules. Okay. Hi. So now let us see these three schedules. In these three schedules, which one is dirty read, which one is unrepeatable reads, which one is lost write problem are facing, let us try to identify actually. So here if you see first one, let us take the schedule 1. So here first of all, don't confuse that. 2 meaning is this is related to transaction 2, 1 meaning is this is related to transaction 1, and in this way you are going to execute them. So that is what. So most of the times if we are going for the object oriented questions, so sometimes you may have transactions like this also to save the space actually. Okay, fine. So now if you take the schedule 1, what kind of problem here we have? So if you see here we don't have any commit operation. So here on data item X you are performing read operation, R2 is performing read operation, and if you see same R2s, that means same T2 transaction performing read operation on the same item. So that means what actually, in between on this X write operation is performed, is it or not? From T1 actually, that is very important, not from the same transaction. From the different transaction write operation is performed. So here one read value you will get, here another read value you are going to get for the X. So that means this is actually unrepeatable read, right? Unrepeatable read problem. Is it or not? So that is what RW conflict. And not only that, of course this is RW conflict, and not only that, if you observe here W1 writing this X value, then this T2 reading the same X value actually. What does it mean? You don't have any commit operation here. That means T2 is reading uncommitted data. So this is very serious problem. This is actually a dirty read problem. So this is dirty read problem. This is very serious problem actually. So there should not be any dirty reads in the schedules. So that you have to take care actually. So that is what actually this is WR conflict. First write operation and then read operation you are doing. So this is what I think only these two you have in this schedule S1. Now let us consider S2. So try to identify what problem you have out of these three whatever we seen earlier. So for example, if you take R2 X and you are not reading same X of T2 transaction and R2 Y and here R2 Y, but in between there is no write operation on the same Y. So don't, you see here you have to take care that, you have to careful that on the Y data item in between. So here you see you are reading Y, here also you are reading Y, but in between on the same data item Y, another transaction not performing any write operation. So it is not a unrepeatable read problem actually. But here read operation on the X from T2, here also from T2 read operation is there on the same X. But in between another transaction T1 performing write operation on the X. That is why unrepeatable reads is for getting actually. But here you don't have that problem. So any other problem actually. So here you can see W2 performing write operation which is not committed, that going to read by T1 transaction. So this is calling as what actually? So that is what a dirty read problem, right? So S2 is suffering from dirty read problem. Is it or not? So that is what WR conflict. Okay, this identification is very, very important. And then now come to the S3. So in S3 if you observe, read X from T2 transaction. So you can see read X here, write X here. So here you can observe that W1, W2, W1 writing on X, W2 is also writing on X. So this is what actually lost update problem. So that is nothing but WW write conflict actually. So in this way actually this is one question actually we have to identify in which schedule we have a unrepeatable read problem. So we have only unrepeatable read problem from the S1, but this is going to make you aware that how to identify these three problems from the schedules actually. Hi. So now let us see very, very important thing in this chapter. So that is schedules based on the recoverability. So recoverability is very, very important thing. Whenever something is happened, when any wrong thing is happened, you at least you must be in a position to recover actually the original position. So when you are performing the transaction, if anything is unexpected thing is happen in between, you must be in a position to roll back actually, so that at least you are going back to the original position. So nothing is happened, no, there is no harm to the transaction, there is no harm to the data actually. So that is what recoverability, schedules based on the recoverability actually. So here if you see the first one, non-recoverable schedules, these things you have to handle very carefully. So first of all let us try to understand what is meaning of non-recoverable schedules. So here if you take this schedule, two transactions are there, so that is what T1 and T2. This schedule if you take, this is T1 reading first A value and performing the write operation, fine. Then T2 if you see reading this A value, whatever written by T1, of course that is reading by T2 actually. So that problem is what actually dirty read. So dirty read is there, okay, fine. Sometimes dirty read is fine, that is leading to problem when actually. So that part let us see actually. So it is reading value, and basing on that value something is happened in between, and finally you are performing write operation. Then after writing you committed actually, T2 is committed actually. So here we have a dirty read and you committed, T2 is committed. Now come to the T1 now, of course it is doing some other thing, so reading a value. After all operations are over, if it is committed, there is no problem for T2 also. If T1 is committed here after this operation, no problem for the T2. But if it is abort, what is going to happen? All these operations are going back to rollback. So it is going back to original position. But rollback is not possible here actually. Rollback is not possible. Rollback not possible actually. Very serious problem. Because you are already committed. Committed means making the changes permanent. So after that if you try to roll back, it is not going to happen actually. So that is what you are not in a position to recover the transaction. You are not in a position to go back to the original position of the data actually. So that is what non-recoverable schedule. This kind of schedule is actually non-recoverable schedule. That is only because of reading dirty data. That means a dirty read problem is there first of all, and of course here abort operation is happening. So this is what one simple example that non-recoverable schedules. Hi. So in the last lecture we seen that non-recoverable schedule. So now let us see how recoverable schedules are going to be there. So that means see ultimately as name implies recoverable. So at least we are able to recover the original data actually, that is what. So now if you see in this recoverable schedules, what is going to happen? So same thing, same operations we taken, the only change is in the commit operation actually. So now here T1 reading a value, writing back, then reading this a value. So this is going to become dirty read again, same thing. Then it is writing back actually, but it is not yet committed, that is very important. So position of the commit is very important actually. Now it is switching from T2 to T1, then a item already it is going to read, and then for example this is committed first. So this is committed first. So commit is performed. After that assume T2 transaction is committing. So now there is no problem actually. So why there is no problem is, suppose if any abort is there, see if it is committed and then it is committed, there is no problem, database is in a consistent state. But if it is aborted, it is going to roll back. So because of T1 failed and because of T1 updated value you read, so what you have to do by that time you are not yet committed, so you also have the chance of aborting the transaction. So that means you are also in a position to roll back actually, that is very important. You are also, T2 is also in a position to roll back. So T1's failure leading to T2's failure, so T1 is able to abort, that means T1 is able to roll back. So T2 is also able to roll back because of T2 is not yet committed. Because T2 is committing only after T1 is committing. Because T2 is reading uncommitted data which is written by T1. So whenever dirty read is there, your commit operation position is very important. So this is actually recoverable. So you have a schedule, but this is recoverable because of the position of the commit actually. So that is very important actually. So this is called recoverable schedules. Hi. So now let us see the next one, that is cascading rollbacks. So this is as name implies actually, nothing is there. So if you observe, let us take the 3 transactions in this schedule. So how and all we have transaction T1 first performing. So read A item and write back the A item, and after that T2 is reading the A item which is written by T1 actually. So this is nothing but a dirty read. Okay, fine. So this is also writing back the A value. Then T3 is reading the value which is written by T2 actually. But by that time, because it is not committed, so this is also a dirty read. Is it or not? Here we have a dirty read, here also we have a dirty read. So that is not a problem actually. Dirty read is not a problem. Because of the dirty read, where is the position of the commit? That is what is actually the important thing. Okay, in this case, for example, first of all, there is no problem assume. So what is happening is, first T1 is committing. So first T1 is committing. Okay. After T1 is commit, T2 is committing actually. And then T3 is committing. So now if you observe, because here at T2 you have a dirty read, but this dirty read there is no problem, because after T1 commit only T2 is committing. Because of that reason, if any rollback is happening, it also can roll back. Here also dirty read is there, so observe the commit operations. From where you have a dirty read, that transaction first committing, and then you are committing, T3 is committing. So in this committing there is no problem actually, you can recover the data back actually. So what is going to happen? For example, if it is rollback, so that means this transaction is aborted. Then what is going to happen? It is rollbacking. So because by that time T2 not yet committed, so it also can go for the abort actually. So it also can roll back. And by that time T3 also not yet committed, so it also can go for the abort operation. So that means it also can roll back. So what is the problem here is, this kind of schedules are also not recommended, because here you see, as name implies, cascading rollbacks. One transaction failure leading to other transactions failure actually. Because in this path, if any one transaction is failure, all subsequent transactions has to abort actually. That means all other transaction has to roll back. So this is cascading rollbacks actually. So simply one transaction failure leading to all other dirty read transactions are also going to fail. So that is why it is named as cascading. So this is called cascading rollback. Hi. So now let us see the next one, that is cascadeless rollbacks. So you can observe that cascading rollbacks we seen, so opposite to that cascadeless rollbacks actually. So you can understand that when you are going to have a cascadeless rollbacks, so it is very simple, you just observe this one. So first of all, it is reading a data item A, transaction T1, and writing back actually. Here it is reading B, data item B. This is not at all a dirty read. If you are reading same data item, then that is the dirty read actually. You are not reading the same data item. A is the data item, B is the data item, but here written one data item and you are reading another data item. T2 is reading another data item. So this is not at all a dirty read actually, and there is no relation to this one. So you simply read the data item B actually and written back. Then T1, it is you switch it to T1, then read C data item and written back C data item. Then it is committed, very important. After commit of this operation, this transaction, T2 reading A value and writing back A value, and it is committing. Okay, so now you can see, if this is failed, if it is aborted, then it is going back to rollback. Okay, fine. So are you need to roll back because you didn't read it by that time. So by that time, this is the timing actually. So by that time you didn't read A value actually. So you no need to roll back. That is why cascade less rollback. Failure of the one transaction, another transaction no need to roll back, because if it is successful, you are reading the successful data. If it is aborted, you are reading the original data, because by that time it is rollback. So you are reading the original data, there is no problem at all for anything, whether it is committed or abort. So that is what very important, and this kind of schedules are required actually. So because one is failed, so that all others are failing, so that is not a good schedule, right? That is what cascading schedules, rollbacks. But cascade-less rollbacks is actually required schedules. So one transaction failure is not leading to another transaction failure actually. So what you can say from this also, cascadeless rollbacks, cascadeless schedules are recoverable schedules. So because you can recover actually. So that is what actually cascadeless rollbacks actually. So this is one kind of schedules which are recommended schedules. Okay. Hi. So now let us see the next schedule, that is strict schedule actually. So here it is very simple. So it is very strict. Why it is called a strict schedule? So very simple. So you can see read A, write A, commit or abort, whatever that. After that only you want to read that same data item. Simple. So transaction T1, first it is performing on the data item A, that may be any operation, read operation or write operation. Then after that, that transaction you want to read that same data item after that particular transaction either commit or abort. So either updated value which is committed so that permanent, or abort so that going back to original value. So any one of these two after performing, then only if you are committed to read that A value, then this is very strict schedule actually. So that is very simple one. So you are always very strict that whatever data you are going to read, that data item already read and write by some other transaction. So you are going to read only if that particular transaction either commit or abort. That means either committed so that updates are going to become permanent, or aborted, that means going back to original value. So in both the cases only you are going to read or write, performing a write operation. Otherwise you are not going to read actually. So such a schedules we are calling as very strict schedules. Okay. Hi. So till now we seen that strict schedules, cascade-less schedules, recoverable schedules. So you see these three words are positive words towards this concurrency control actually. Strict schedule, there is no problem. Cascade-less schedule, that is also no problem. And recoverable schedules, that is also no problem actually. So non-recoverable is not a good thing actually. Not strict is not a good thing actually. Cascading schedules is also not a good thing actually. So if you take a strict schedules, so every strict schedule, so first one is every strict schedule is cascade-less schedule actually. Cascade-less schedule. Okay, so what you can write down? So here if you see, so strict schedules are cascade-less schedules. So cascade-less. You don't need to roll back if any transaction is failed. So that is what cascade-less. So every strict schedule is a cascade-less schedules. And at the same time we discussed at this point, every cascade-less schedule, every cascade-less schedule is recoverable. That is very important. Is recoverable. Because of the commit operations you can go back cascadeless schedules actually. So that means every cascadeless schedule is recoverable means, so you can write down like this, you can give the relation like this, that is what recoverable schedules actually. Okay, so that is what actually strict schedules are both cascadeless and recoverable schedules actually. So from that you can write the inference point. So strict schedules are both cascadeless and recoverable. Okay. So this is one important point for basing on our discussion actually. So every strict schedule is a cascadeless, every cascadeless is a recoverable schedules actually. Okay, and between among these three, this is the relation. Okay. Hi. So now let us try to practice few questions. So till now we seen the theoretical concepts. So let us just apply those concepts on the some examples actually. So now onwards we are going to see some set of problems actually, more than 10 problems we are going to practice, so that whatever concepts we learn till now, those are going to become permanent actually. So that means you are going to understand much better. So that is what, if you take the first example here, so you have to identify whether you have a dirty read or not, whether it is a cascade or cascadeless, recoverable or not recoverable. So all these things you have to try to identify from this actually. So that is what, first of all if you see, is there any dirty read? So dirty read meaning is what? Reading the uncommitted data. But if you see transaction 1 reading here original value of x, and transaction 2 also reading original value of x only. So that means no transaction is reading uncommitted data. So that means what you can write down here. So first one is no dirty read. So that is good thing actually, no dirty read. And when next immediately you can write down what actually, if there is no dirty read, so there is no much dependency among these two actually. So that means there is no cascadeless, is it or not? So it is a cascadeless schedule. So that is good thing actually, cascadeless schedule you can write down. Okay. Then, and it is cascadeless, what you can say actually, because there is no dirty read, so you no need to depend on the commit operations. So that means it is recoverable. So that is what actually recoverable. Okay, this is a recoverable schedule. And another one is you are not reading the data which is either committed or aborted data. So you are simply reading the original data from both actually. So that is why it is not strict schedule, not strict schedule. Okay. So that is what actually, from this transaction you can write down these four. So there is no dirty read, so that is why no cascadeless, it is a cascadeless schedule, and it is recoverable because there is no dirty read. So these two things almost depends on this dirty read actually. If you have a dirty read, then you have to go for the commit operation, where the position of the commit operation in the both transactions actually. So that is why if there is no dirty read, you can write cascadeless and of course recoverable. Okay. Now let us try to apply same thing on this one. So try to identify whether it is a dirty read is there or not, the first thing. So you can see here write operation of x and here read operation of y. So here it is reading a item actually, but don't think that it is reading the same item. When you can say it is a dirty read, it is writing x and it is reading y. Here write on a data item is different, read on a data item is different. So this is not at all a dirty read. Okay, then fine. Next, here if you see, here you return the value and till here you don't have any commit operation, and here you are reading the same data item, very important. So this is dirty read. So here we have a dirty read problem. So this here we have a dirty read actually. So because you have a dirty read and you don't have commit operations here, if it is aborted, you also have to abort. So that means what actually, it is a cascade schedule, is it or not? So it is a cascade schedule. So cascade schedules are not recommended. failure of one transaction leading to other transactions are also failure actually. So that is not a recommended thing, right? If one is failed, others should not affect actually at least. So that is what you have to make sure. But here, because of the dirty read you have, if it is committed, there is no problem. If it is aborted, you are also aborted because you are reading a dirty value. That means not a consistent value. So that is what cascade schedule you have. After that, recoverable or not. So recoverable or not, that is basing on the commit operations we have. So here if you have commit and then here if you have a commit, then that is not a recoverable actually. So what we will do is, for example, I am giving like this. So here if you have a commit and then here you have a commit. Then if it is aborted, you are unable to abort, right? Because you are already committed. So that means you are unable to roll back. So in this case, you can write down as not recoverable. So this is just depend on the position of the commit in both, okay. And of course this is not a strict schedule, okay, not strict schedule. So this is what from these two these things we can identify actually.
Hi. So till now we've seen that different definitions. Okay. So now let us practice basing on the schedule. Let us identify that is belongs to which definition actually. Okay. So if you observe this schedule, T1, three transactions are there. So we are going to have a two data items X. Okay. In these two also X and Y. So here data items are X and Y. So data items are X comma Y actually. That means on these data items you are performing some operation that may be read or write. Okay. Now first thing is always try to identify is there any dirty read or not. So here read X. So before that there is no write operation. Read Y. Before this there is no write Y actually without commit. That is what the dirty read, right? Dirty read meaning is what? Reading a uncommitted data. So do you have any uncommitted data read? Because you must have write operation. So no. So this is write X. So leave it. So read X. So now if you observe, this is the reading the value of X, data item X, which is written by this transaction. So that means this is what dirty read. Is it or not? So we have a dirty read problem. So here it is reading uncommitted data. So dirty read problem we have actually. So dirty read is not a problem, but after that, if basing on the commit operation, you have a problem actually. So that is why let us leave it as a dirty read only. That's it. So it is a dirty read. Now, whether it is recoverable or not, that is purely based on the commit operation. Is it or not? So let us go for different things actually. For example, this have a dirty read. So if it is committing first, and then this is committing, then what is happening? If it is aborted, it is unable to abort, right? So this color meaning is, this color if you meaning is what actually? Not recoverable. Is it or not? Not recoverable. So that is what, because commit operation of the T2 first, because it have a dirty read which is written by T3 and T3 is committing after T2, so it is not recoverable actually, this schedule. So let us take another possibility. So that is, for example, if T3 is committing first and then T2 is committing, this color you treat separately. Okay. So at that time, what is going to happen? It is recoverable. If T3 is aborted, T2 also can abort actually. So that is what, in this case, it is recoverable. So in the exam or somewhere, they will give clearly actually where the commit operation, where the abort operation. So if it is committed, so no problem, the T2 also can commit. If it is aborted, so T2 also can abort actually. So that is what you can go for the rollback. So because it is recoverable and cascading rollback or cascadeless rollback, if T3 is rollbacking, T2 also have to roll back actually. So that is what it is, a cascading rollback. So its rollback depends on other transactions actually. So is it a strict schedule? No, because you have a dirty read. Because it is reading the uncommitted data. Strict schedule meaning is what? Reading the uncommitted data. So that is why it is not strict schedule. Is it? It is not strict schedule. Okay. So that is what actually, basing on this discussion, you can say if commit operation is like this, first of all, it is a dirty read. If commit operation is this one, then it is not recoverable. So there is no further discussion. But green color, consider this side actually. If a T3 committed first and then T2 committed, then it is recoverable, cascading rollback, and not strict schedule actually. Okay. In this way, we can decide actually. Hi. So now let us see another problem. So if you observe this schedule, 3 transactions are there. So T1 is starting first. So reading data item X. So always it is recommended that first you identify whether dirty read is there or not. So how you can see? So read item X. So because this is the first operation, so leave it. And here read Y. So this is also, before that you don't have other transactions write operation on Y actually. So that is also not a problem. So write X. So till now T1 is only working. So you don't bother, skip all of them actually. So if you have a group of operations performing by the same transaction initially, you just skip. Directly go to the operation which is done by another transaction. From there, you start actually working. So read Y. So check that whichever transaction before that done some operations upon those, in those, is there any write operation on the same data item Y? So we don't have same data item Y write operation. So it is not a dirty read actually. So go here actually. So here also this is write operation. So leave it. This is write operation, leave it. But here you have a read operation. So check that before that on the same data item Y, do we have read write operation? So yes, here we have a write operation actually. So that means this is a dirty read. So we have a dirty read actually. So if you have a dirty read, whether it is recoverable or not, that depends on the commit operation. So as usually, basing like a previous problem, so what we will do actually. So for example, this is committing first, and then T3 is committing next actually. So you have a dirty read at T2 actually. So that is what, because T2 is committing first and then T3 committing. So if T3 is rolled back, T2 unable to roll back because it is already committed. So it is not recoverable actually. Is it or not? So this is not recoverable. So that's all. So when it is not recoverable, though you don't have any other option actually. So now let us see if this is committing first, that means T3 is committing first and then T2 is committing. So in that case, so same discussion like earlier, it is recoverable. So if T3 is rolled back, T2 also can roll back. So that is what it is recoverable actually. So we'll write down recoverable. And same time, because it is recoverable, but T3 is rollbacked, so automatically T2 has to roll back. So that is what actually cascading schedule actually. This is a cascading schedule. Okay. and cascading schedule, and it is not a strict schedule because you have a dirty read operation. So not strict schedule. Okay. So this is what the problem 4 actually. Hi. So now let us see these two problems actually. So that is the first problem is this one, schedule T1, T2 we have. So here first thing is whether we have a dirty read or not. So first of all, this is the only read operation and we don't have any other read operation actually. So what we can say, there is no dirty read first of all. So that is what simply you can say that no dirty read. Is it? Yes. After that, because there is no dirty read, and if it is aborted, so it is already aborting. Because of this aborting, this is but this is committing, but there is no problem actually. It is recoverable, is it or not? So first of all, there is no dirty read, so it is recoverable always. So that's it. Then whether it is a cascading schedule or cascadeless schedule actually. Okay. So this is this write operation performing, this write operation is performing, but this is a cascadeless schedule actually. Is it or not? So this is cascadeless schedule. Because of there is no dirty read. So what you can say actually, because it is cascadeless schedule, so you can say it is strict schedule. Okay, so that is what about this problem. Now let us take the next one. So you can see all operations are same, only the change is this is the commit operation. So now you can see here, no dirty read, no dirty read. Okay, and it is also a recoverable. So this is also cascadeless schedule. This is not making any change actually. There is no cascading required. And of course, this is strict schedule. You are not reading any uncommitted data. Okay. Hi. So now let us see another schedule. So here if you observe in this schedule, T2 is reading the first data item X, and then T3 performing write operation on X, and it is committing actually. So the very first thing is whether we have a dirty read or not. So where we have a read operation, here we have a read operation on Y actually. So now it is reading the Y value actually. So is there any write operation on Y by from other transactions? Yes, we have here. But that is already committed. So that means changes on that data item Y make the permanent actually. So you are reading here. So that means it is not at all a dirty read. If you are reading a uncommitted data, then that is actually dirty read. But here, because it is committed, it is not at all a dirty read. So not dirty read. Okay. Then, so after that, is it recoverable? So there is no dirty read first of all. So it is recoverable actually. So it is recoverable. Then after that, so is it a cascading schedule or cascadeless schedule? So because you don't have dirty read, so it is there, you no need to cascade actually. Okay, so that is what cascadeless schedule. Cascadeless schedule. Okay. And then is it a strict schedule? So you can see here only we have a read operation that is reading committed data. So it is a strict schedule. That is very important. Okay. Now, same way, let us see the another problem. So this one in this schedule. So here you can see read operation. This is the first one, write operation, and write operation, here read operation. But here is the read operation, but that is reading committed data. So simply you can write down no dirty read. So good thing that no dirty read, and it is recoverable. So same discussion like previous problem, it is recoverable, and it is actually cascade-less schedule. Is it or not? You no need to cascade actually basing on other operations abort or commit. Okay, so cascade-less schedule. So that is also good thing, and of course it is strict schedule because it is reading committed data. So it is a strict schedule. Okay.
Hi. So basing on the discussion till now we have, first of all let us try to have a one broad idea, so that wherever we are discussing we are going to have a clarity actually. So that is what actually we are going to see simply a classification. Okay, basing on the discussion till now we have different words we already discussed. So that is, if you take any schedule, so we are going to have a schedule. So these schedules are two types actually. One is serial schedule. So one is serial schedule. So what is meaning of serial schedule? So operations of one transaction completely executed, after that another transaction operations you are executing. So that means one transaction, then another transaction, and then another transaction. So like that you are going to execute. So if it is a serial schedule, first of all you don't have any problem actually. Always database in a consistent state. So you no need to bother. Simply you are going for simply you can believe that always database is in a consistent state. No problems actually. But what are the problems because of serial schedule? There may be a long waitings. You are not going to efficiently utilize CPU and IO resources actually. So those drawbacks we already discussed if it is a serial schedules always. So that is why to improve the performance in all the ways, we are going for non-serial schedules. So non-serial schedules actually. Okay, fine. So in the non-serial schedules you are going to face some problems actually, or every non-serial schedule, that means what actually? Non-serial schedule meaning is some operations from one transaction you are executing, after that you are switching to some other transaction, and some operations you are executing there, and then coming back to previous transaction, and then you are executing remaining operations like that. So that means you are mixing the operations of different transactions actually. When you are doing like that, we are going to have again two kinds actually, that is recoverable schedules, and oppositely non-recoverable schedules. So that is, so if it is non-recoverable, so then it is always not recommended actually. So there is no further discussion. So if it is non-recoverable schedule, you simply leave it. But if it is recoverable schedule, in what way it is recoverable? So one is cascading schedule, uh, cascading schedule, and another one is cascadeless schedule. So this is what actually overall classification here. So cascading schedule, of course it is recoverable, but in what way? One transaction is failed, due to that all other transactions are also going for fail actually. That means going to roll back. But here they are not going to roll back actually. If one transaction is failed, other transactions are not going to affect actually. So that is what cascadeless schedule. So always recommended is this one, a schedule which is non-serializable, recoverable, and cascadeless schedule is actually the best one. So we are going to try to identify such a type of schedules actually. Such a type of non-serial, recoverable, cascade-less schedules actually. So till now whatever individual discussions we have, so that you try to combine in this way, and whenever you are going for non-serial schedules, what kind of schedules ultimately we need? Ultimately any non-serial schedule must be recoverable, and if it is a cascade-less is the best one, and sometimes you have to go for the cascading schedules also if you do not have any option, but always recommended and best schedules are cascade-less schedules. So this is what first of all try to get the broad idea of this total discussion. Hello all. So now let us see very important concept in transactions and concurrency control. So that concept is serializability. So whatever we discussed till now, that is all preparation for understanding this concept actually. So how concurrency we are achieving, what way we have to achieve, what way we have to authenticate. So all those things we are going to understand from this discussion actually. So first of all, let us try to understand its definition, and to make this more clear, let us try to understand these examples actually. So first of all, we are going to have a clarity that what is serializability. So for that, let us see first of all its definition. So if you take here a schedule S with n transactions, very importantly we have n transactions. For example, this is one schedule, here we have two transactions. So schedule S1 with two transactions, so simple. So S with n transactions is said to be serializable. So that is what serializability actually. So when you can say schedule S is serializable if it is equivalent to a schedule S dash, very importantly S dash with the same n transactions, where S dash is serial schedule, S is the non-serial schedule. So very important one. So S dash is serial schedule and S is the non-serial schedule. So this is what actually the first of all concept. So let us try to understand this definition with these examples actually, because in the next discussion whatever we are going to see in the next, all that depends on this definition understanding only. So to achieve this definition, we are going to have supporting discussion actually in the after this actually. So that is why let us try to understand this one with this simple examples actually. So what we are going to do is ultimately here, let us see first of all this S1 transaction, S2 transaction, S3 and S4. So if you observe S1, S2, S3, S4, first of all what is our understanding? S1 and S2 are serial schedules. If you observe, those are serial schedules actually, and S3 and S4 are non-serial schedules. S3, S4 non-serial schedules actually. Okay, so that's it, let it be. So very simple understanding, let us come here. So in the S1 if you observe, in the S1 it is reading data item, T1 is reading, T2 is reading data item B. So two data items you are going to read in this S1 schedule. So let us take S1, let us take A value initially as 1000, B value initially as 500. So that is what. Now in this order if you do, what are the final values? So let us see here. So A is reading 1000, so it is 1000 initially, and then 10% of A it is calculating actually, so that is 100. That 100 you are adding to A actually, so it is going to become 1100, that you are writing back into the database. So on this database you are going to write back that 1100. So let it be, no problem. Now after that if you see T2 transaction, because after this you are doing this part, right? You are reading A item, so that is 1100, okay, and you are reducing 100 from the A actually. So this is going to become 1000 back, and that you are writing back. So that means here only that 1000 you are writing back actually. So it became overall 1000 after this step. Then reading B, so that means 500, and here adding this 100 here, so it is going to become 600, that you are writing back into the database. So that data item B is going to become 600. So this is what after this actually. So if you observe in the S1, first you are completely doing T1 operations and then you are performing T2 operations. So T1 we are doing first and then T2 we are doing, that is what you can observe actually. So let it be, this is final answer, so these answers let it be. Now come to the S2 actually. So in case of S2, what is our observation? So first T2 you are performing and then T1 you are performing. So here also initially A values are same for any schedule actually. So B equal to 500. Now it is reading A value, so that is 1000, and here it is reducing by 100, so becoming 900, that we are writing back. So this is going to become 900, and then reading B value 500, adding that 100, so becoming 600, writing back 600. So T2 transaction is completed, then you are going for T1. Reading A value, current A value is 900, and finding the 10% of 900, so that is 90, right? Then that you are adding to A, so that is going to become 990. So you are going to writing back. One thing you have to understand, so here this order is T2 followed by T1. So first you are performing T2 and then you are performing T1 operations. So these two are the serial schedules. Any serial schedule, final answers are consistent actually. There is no problem at all, though their final answers are different, but those are the consistent values, because basing on the transaction you are performing in that serial order, final outputs will be there. So that is why always remember that if you have n transactions, n factorial serial schedules are possible. That is what we discussed earlier. Here we have two transactions. So two transactions T1, T2. So first T1 and then T2, or first T2 and then T1. Any schedule final outputs are consistent. That is what we have to understand very firstly. So though their final answers are different, basing on the transaction you are performing first and then outputs will be vary, but those outputs are consistent, always correct values actually. We have to treat like that only. So that let it be. So this is not at all a problem. Now let us go to the non-serial schedules S3 and S4. Now then we will come back to this definition. So this is very simple. Whether it is a serial schedule or non-serial schedule, initial values are same. So 1000 here, B is 500. So let it be. Now let us come here, T1 reading A value, so that is 1000. After that switching to T2. So T2 also reading A value, that is 1000. At that moment A value is 1000. Now it is reducing by 100, so becoming 900. Writing back that 900 into the database. So that is what 900. Now you see, by the time you already read the A value, upon that value you are going to perform this calculation. So that means 10% of 1000 is 100x, then that you are adding to A going to become 1100. Then after this again you are switching back to T2 actually. So reading B value 500. So for the 500, 100 we are adding, so becoming 600. So that 600 you are writing back, so that is going to become 600. Now you see very importantly, then again switching back to T1, that is writing of A. So it is writing back 1100. So this is very important discussion. Try to understand that final A value is 1100, B value is 600. So 1100, 600, is there any serial schedule producing that output? That means this pair 1100, A is 1100, B is 600. So here A is 1000, B is 600. A is 990, B is 600. So any serial schedule not giving this output. So this is not a valid schedule actually. So that is what you just come back to this definition. S is a non-serial schedule. S3 is a non-serial schedule. S dash, that means serial schedule, any serial schedule. So that is what here if you observe equivalent. So if S is equal to any S dash actually, any serial schedule, if S is equal to any serial schedule, then you can say such a non-serial schedule as serializable. That is what actually the concept. So now let us get the more clarity after understanding S4 also. So now let us run the S4 now. So here if you see A value, so A initially 1000, B is 500. So that is what 500 you can take. So now, so reading A value 500, 1000, it is 1000 initially, reducing 100 by 100 from 1000, writing back actually that 900 you are writing back. So 900. Now, here you are reading A value, right now it is 900. Now 10% of this A, so that is 90, that you are writing, adding here, going to become 990. Then you are switching to T2 transaction. So here reading B value 500. So adding that 100, 600, writing back in the database. So that is what 600. After that switching to T1, then writing back that result actually 990. Now if you observe the S4 results, S4 result is A value 990, B value is 600. So 990, 600, is there any pair here, any serial schedule producing that output? So that is what 1000, 600, 990, 600, 990, 600. So S4 schedule with two transactions, S4 schedule with two transactions is said to be serializable if it is equivalent to schedule S2, equivalent to schedule S2 with the same two transactions where S2 is serial schedule, S is non-serial schedule. So that is why you can say S2 is actually S4 is equal to S2 actually. So you can say S4 is non-serial, S4 is actually a serializable schedule. So now let us see why this concept actually. So that is non-serial schedule and S2 is serial schedule, and we know already that benefits of non-serial schedules. So recommended is non-serial schedules, but consistent is any serial schedule. So whichever non-serial schedule giving the outputs equal to any serial schedule, such a non-serial schedules we are going to consider, and those non-serial schedules we are going for the execution, because all non-serial schedules are not giving the consistent results. So S3 is not the consistent, is not giving the consistent results actually, but S4 is giving consistent results which is equal to serial schedule S2 output. So that is what now you can easily understand this definition. To achieve this definition only, we are going to discuss next concept, very important actually. Okay, so ultimately non-serial schedules are recommended, but every non-serial schedule is not going to give you consistent results. So that is why which is non-serial schedules are giving consistent results, that means those are equal to any of serial schedule outputs. So such a non-serial schedules we need actually. So that is what serializable, because this is giving a output like serial schedule output. So then you can say such that though it is non-serial, but you can say it is serializable. Serial is different, serializable different. Serializable means one of the non-serial schedule giving the output like a serial schedule. So, such a non-serial schedule you can call as serializable. That concept overall we are calling as serializability. So, this is really very important, though it is taking some time, because whatever we are going to discuss in the next, to understand those things clearly, this lecture especially must be very clear. Okay. Hi. So, now let us try to understand some important things actually for supporting our next concept. So, that is, we already understand that what is the serializable, what is the serializability concept. So, from that actually, first of all, this must be clear that if you have a n transactions, how many serial schedules are possible? So, that is answer is simple, n factorial serial schedules are possible. How and all? For example, T1 we have, T2 we have. So, T1, T2 two transactions are there. In what way you can execute them? So, first is T1 and then next is T2, or first T2 and next T1. Or for example, if you take a simple example A, B, C. So, how many ways you can put them? That is what permutation concept, right? So, permutation means what actually? For example, you can see three positions, who has to place them actually. So, in the first position if A is there, then in the next position either B or C. So, in the next position A B already done, C is there, A C already done, B is there. Or in the first position if B is there, so in the next position either A or B. So, B A already done, so C, so this is C actually, okay. So, B C, then A will be there. Or in the first position if C is there, either A or B, and then B or A. So, if you observe this, how you can consider actually, this is just permutation concept only. So, in the first position out of 3 persons, any one you can select. How many ways you can select? 3 ways you can select. Any one, either A I can select or B I can select or C. So, 3 ways we have. So, by the time you come to the second position, one person already fixed. So, you have only 2 persons, but that means for example A is fixed. So, only within B and C you have to select. So, that means you have 2 ways actually. So, like that you have 1 way. So, total how many permutations are possible with 3 persons? That is what 3 factorial, right? That is nothing but 6. So, that is what actually, if you have n transactions, how many serial schedules are possible? N factorial serial schedules are possible. And every serial schedule out n factorial, among the n factorial serial schedule, any serial schedule is consistent. So, any serial schedule you can take, that is fine actually, no, not at all a problem. That is what we already concluded in the last lecture. Now, very importantly, come to the number of non-serial schedules actually. Now, here also, how many non-serial schedules are possible? So, that is what formula wise we have to understand. So, assume that I am giving directly the formula first of all. Number of non-serial schedules are, okay. So, n1 plus n2 plus n3 and so on, n suffix m. So, this total summation factorial divided by n1 factorial into n2 factorial into n3 factorial multiplication actually. So, like that nm factorial. So, here factorial is there. So, where so n1 is number of ni, you can take simply for everyone, number of operations in ti transaction actually. So, it is like we have a read write operations, right. So, how many read write operations are there totally? Read A, read B, write A, write B, total 4 operations. So, 4 operations are there in TI transaction. So that is what, when one operations are there in T1 transaction, N2 operations are there in T2 transaction, so accordingly actually. And where M is number of transactions, total number of transactions. So from that easily we can understand. So this is what actually the formula. So for example, T1 we have 5 operations, T2 we have 3 operations. Then how many non-serial, actually try to understand how many non-serial schedules are possible, that is what we are trying to tell. So here from this 5 plus 8 factorial by 5 factorial multiply 8 factorial. So the final answer is 56 actually. So 56 non-serial schedules are possible actually. So some of them may be consistent, some of them may be not consistent, but that is not the point actually here. So here total how many non-serial schedules are possible? So 56 non-serial schedules are possible actually. So that is what actually if you have a n transactions, how many serial schedules are possible, how many non-serial schedules are possible, formulas these two actually. Okay. Hi. So now let us see types of serializability or equivalence. So we already understand what is serializable. Okay. So one thing, if you see, ultimately we need a non-serial schedule which is equal to any one of the serial schedule actually. So first of all, this simple example only let us take. So in the last lecture this is what we discussed already. So hope you already done this part. So now if you see from this, if you take a 2 transactions only which have 5 operations and 3 operations from those 2, total 56 non-serial schedules are possible. So 56 non-serial schedules are possible, and some of them may be consistent, some of them may not consistent actually. So which non-serial schedule is consistent, which non-serial schedule is not consistent. So which are consistent only we need actually. In this 56 only, some of them is consistent, some of them is not consistent. So how you will identify them actually? So are you going through all 56 non-serial schedules? No, that is not recommended, because if you have just 2 transactions only, this many possible means you can understand in the real time every day at every moment how many transactions are happening, and in each transaction how many number of operations are going to be there. So that is why you have to identify non-serial schedule which is serializable. So for that purpose we are going to have a types actually. So the first one is conflict serializability, conflict serializability, and another one is view serializability. So you may have other one more thing actually basing on the equivalent serializability, but that is a result based serializability, but that is not a big thing actually, very small one. But here if you observe conflict serializability 1, which you can use to identify a non-serial schedule which is equal to a one of the serial schedule actually. So that's to which serial schedule it is equivalent also you can find out from these two actually. So that is what our next discussion, by using conflict serializability how you will identify, by using view serializability how you are going to identify, that is what our discussion actually. Okay.
Right. So now let us see our next concept in where clause. So actually till now we've seen that in the where clause writing only with one condition, but sometimes we have to go for different conditions actually, and different possibilities will be there. Okay, so sometimes either or condition, or sometimes both the condition. So whenever you have more than one condition and basing on the situation, you are going to have another operators, that is the and operator or operator not operator. So these things, especially and are using for connecting different conditions actually. And of course, and is different, or is also different. Okay, their meanings are different. So let us see. Okay, so that is what actually and or operators are used to filter the records based on more than one condition especially. So if one condition is there, simply we can write down basing on the previous discussion, last lecture we seen. But when you have more than one condition, we need connectors, that is and or. Okay. So let us see the and operator. So and operator, when the condition, overall condition is going to become true. So we have a condition 1 and a condition 2. And in between, you have a operator and. When it is going to return true overall, that particular record is going to return when condition 1 is true and the condition 2 is also true. So this part you might have seen in the digital logic or any mathematics, okay, somewhere you might see, but the same meaning is same. Both the conditions must be true, so that overall condition true, so it will return that particular record. That is what, when it will display a particular record, if all the conditions separated by and are true. Even not only these two conditions, you can have more than this also. All conditions must be true, then only that particular record is going to return or display. So same way, when you are going to display or record, if you use the or operator, at least one actually. So any one of the condition, if it is true, then overall it is true. Or if all conditions are false, then only it is not displaying. At least one condition, if it is true, then entire record, entire condition is true, so that that record is going to display. So that is what simple not operator is what. So simply it is negation, right? If condition is true, so we are going to have a condition. Before that, if I write a not true is actually a false, not false is actually a true. So that means you see the not operator display a record. If the condition is not true, that means if it is false, if the condition is false, then not false is nothing but true. At that time, this record is going to return. That means actual condition must be false, so that overall it will become true. Then it will display the record. So let us write down simple queries so that we will get familiar actually. List the clerks whose salary is greater than 1500. So what is your understanding here? So here you see employee salary must be greater than 1500. Is there any other condition? He specifically mentioned that clerks actually. That means this is one condition and this is another condition. Got it? So that is what, first of all, select command, select. Then we need all columns. So that is why star, and from which table? From EMP. Okay, fine. This is simple. Then where condition part, which rows we need actually. So employee must be a clerk actually. That means job type must be clerk. So that is what, job is equal to clerk. Not only this, his salary must be greater than 1500. So what is the operator you have to use among these three? And actually, whoever clerk, whoever salary 1500, both actually. That is why we are going for the operator. And then salary column is this one. So sal must be greater than 1500, even not equal to 1500. So that's it. So now if whoever satisfies this condition, both, that you can observe actually. Here job is clerk, fine. Salary is less than 1500. So this record not returning. And so clerk, here you have another clerk. His salary is 1100 only. So he is also not going to return. Clerk 950 only, clerk 1300 only. So it is not returning actually no records. It will return 0 records. For example, here if you give 1000, what will happen? This record and this record, 2 records it is going to return. So nothing wrong with 1500. Only thing is no output actually. This statement is correct. This query is correct. Only thing is both the conditions, no record is satisfying. But if you write down 1000, then two records are satisfying, clerk and level greater than 1000, clerk greater than 1000. So Adams and Miller satisfying this condition. If it is 1000 actually, especially. Okay. Now let us see another query. So here list all employees who are either manager or working in the department number 10. So how we can write down this? So here if you observe that we need employee details, either he is a manager or working in the department number 10. That means you see or operator, any one actually, need not be both, at least any one of them. So that is what simple. This is simple, right? So select star from EMP. So where what we can write down? So manager. So job type either manager. So job is equal to manager. Or this is important. You see anyone actually. Or department number is 10. So DEPT number is 10. Equal to 10. So whoever satisfy any one of this actually. So you can see simply the first record. So the first record, it is not 10 and not manager actually. Next, not manager and not 10. So let us see, these three are satisfying. So let us note down here, these three are satisfying because manager. And there is no manager further, but this is 10, this is 10. So total here 3, here 2, total 5 records it is written. Is it or not? Because anyone actually, manager or department number 10. But here if you observe one record satisfying both. But that is not a matter. If at least one of them is true, then other not required. And one more thing, if you see, especially this we will use in case of optimization part, you return job equal to manager, department number equal to 10. So if this condition is true, first part if it is true, job is equal to manager, then it is not going to evaluate remaining because the operator is or. If one of the condition is true, then overall it is true. So it is no meaning that if you evaluate further also. So that is why remaining condition part it is skipping. If first condition is false, then it is going for the other condition. Even here also in case of AND operator, if first condition is false, then overall it is going to treat as a false because as mentioned that in case of AND operator, all conditions must be true. But if your first condition is false, then there is no meaning of executing remaining actually because overall it is going to become false. So that is what in case of optimization, these things are going to be useful. And that is why actually job equal to clerk, salary greater than 1500, which you have to write down as a condition 1, which you have to write down as a condition 2, basing on the data you have actually. So those things we will see in a separate lecture actually. So this is just for the information how to use these operators. Okay. And then let us see one more example for not also. So here you can see the list employees who are not managers. So how you can write down for this? So you see by using not operator, let us try to find. So you can see here select star from EMP where so you see if I write job equal to manager, only managers will come, but job should not be manager actually. Then operator not we are using in front of this condition. What is going to happen? For whoever the manager, for them condition is going to become true. So not true is false overall. Whoever not manages, this part, condition part is going to become false. Condition is going to become false. Not false is actually true. So it is true is becoming for whom actually? Whoever not manager. So that is what required, right? So whoever not manager, all those employees details it is going to display. Is it clear? So in this way, in simple manner, we can write down actually. Okay. Right. So now let us see our next concept in where clause. So actually, till now we've seen that in the where clause, writing only with one condition. But sometimes we have to go for different conditions actually. And different possibilities will be there. Okay. So sometimes either or condition or sometimes both the condition. So whenever you have more than one condition and basing on the situation, you are going to have another operators, that is the and operator or operator not operator. So these things, especially and or, are using for connecting different conditions actually. And of course, and is different, or is also different. Okay, their meanings are different. So let us see. Okay. So that is what actually and or operators are used to filter the records based on more than one condition especially. So if one condition is there, simply we can write down basing on the previous discussion, last lecture we've seen. But when you have more than one condition, we need connectors, that is and or. Okay. So let us see the and operator. So and operator, when the condition, overall condition is going to become true. So we have a condition 1 and a condition 2. And in between, you have a operator and. When it is going to return true overall, that particular record is going to return when condition 1 is true and the condition 2 is also true. So this part you might have seen in the digital logic or any mathematics, okay, somewhere you might see, but the same meaning is same. Both the conditions must be true, so that overall condition true, so it will return that particular record. That is what, when it will display a particular record, if all the conditions separated by and are true. Even not only these two conditions, you can have more than this also. All conditions must be true, then only that particular record is going to return or display. So same way, when you are going to display or record, if you use the or operator, at least one actually. So any one of the condition, if it is true, then overall it is true. Or if all conditions are false, then only it is not displaying. At least one condition, if it is true, then entire record, entire condition is true, so that that record is going to display. So that is what simple not operator is what. So simply it is negation, right? If condition is true, so we are going to have a condition. Before that, if I write not true is actually a false, not false is actually a true. So that means you see the not operator display a record. If the condition is not true, that means if it is false, if the condition is false, then not false is nothing but true. At that time, this record is going to return. That means actual condition must be false, so that overall it will become true. Then it will display the record. So let us write down simple queries so that we will get familiar actually. List the clerks whose salary is greater than 1500. So what is your understanding here? So here you see employee salary must be greater than 1500. Is there any other condition? He specifically mentioned that clerks actually. That means this is one condition and this is another condition. Got it? So that is what, first of all, select command, select, then we need all columns. So that is why star, and from which table? From EMP. Okay, fine. This is simple. Then where condition part, which rows we need actually. So employee must be a clerk actually. That means job type must be clerk. So that is what, job is equal to clerk, clerk. Not only this, his salary must be greater than 1500. So what is the operator you have to use among these three? And actually, whoever clerk, whoever salary 1500, both actually. That is why we are going for the operator. And then salary column is this one. So sal must be greater than 1500, even not equal to 1500. So that's it. So now if whoever satisfies this condition, both, that you can observe actually. Here job is clerk, fine. Salary is less than 1500. So this record not returning. And so clerk, here you have another clerk. His salary is 1100 only. So he is also not going to return. Clerk 950 only, clerk 1300 only. So it is not returning actually no records. It will return 0 records. For example, here if you give 1000, what will happen? This record and this record, 2 records it is going to return. So nothing wrong with 1500. Only thing is no output actually. This statement is correct. This query is correct. Only thing is both the conditions, no record is satisfying. But if you write down 1000, then 2 records are satisfying. Clerk and greater than 1000. Clerk greater than 1000. So Adams and Miller satisfying this condition. If it is 1000 actually, especially. Okay. Now let us see another query. So here list all employees who are either manager or working in the department number 10. So how we can write down this? So here if you observe that we need employee details, either he is a manager or working in the department number 10. That means you see or operator, any one actually, need not be both. At least any one of them. So that is what, simple. This is simple, right? So select star from, select the star from EMP. So where, what we can write down? So manager. So job type, either manager. So job is equal to manager. Or this is important. You see anyone actually, or department number is 10. So DEPT number is 10. Equal to 10. So whoever satisfy any one of this actually. So you can see simply the first record. So the first record, it is not 10 and not manager actually. Next, not manager and not 10. So let us see, these three are satisfying. So let us note down here, these three are satisfying because manager, and there is no manager further, but this is 10, this is 10. So total here 3, here 2, total 5 records it is written. Is it or not? Because anyone actually, manager or department number 10. But here if you observe, one record satisfying both. But that is not a matter. If at least one of them is true, then other not required. And one more thing, if you see, especially this we will use in case of optimization part, you return job equal to manager, department number equal to 10. So if this condition is true, first part if it is true, job is equal to manager, then it is not going to evaluate remaining because the operator is or. If one of the condition is true, then overall it is true. So it is no meaning that if you evaluate further also. So that is why remaining condition part it is skipping. If first condition is false, then it is going for the other condition. Even here also in case of AND operator, if first condition is false, then overall it is going to treat as a false, because as mentioned that in case of AND operator, all conditions must be true. But if your first condition is false, then there is no meaning of executing remaining actually, because overall it is going to become false. So that is what in case of optimization, these things are going to useful. And that is why actually job equal to clerk, salary greater than 1500, which you have to write down as a condition 1, which you have to write down as a condition 2, basing on the data you have actually. So those things we will see in a separate lecture actually. So this is just for the information how to use these operators. Okay. And then let us see one more example for not also. So here you can see the list employees who are not managers. So how you can write down for this? So you see by using not operator, let us try to find. So you can see here select star from EMP where so you see if I write job equal to manager, only managers will come, but job should not be manager actually. Then operator not we are using in front of this condition. What is going to happen? For whoever the manager, for them condition is going to become true. So not true is false overall. Whoever not manages, this part, condition part is going to become false. Condition is going to become false. Not false is actually true. So it is true is becoming for whom actually? Whoever not manager. So that is what required, right? So whoever not manager, all those employees details it is going to display. Is it clear? So in this way, in simple manner, we can write down actually. Okay. Hi. So now let us see one simple problem under primary index actually. So for better understanding of this concept. So let us see first of all, what is the question here? Consider a file of 30,000 records actually. So total records, how many we have? So total records are 30,000. Let us make a note. Yeah. And then stored in a disk with block size 1024 bytes actually. So this is meaning is what? Block size given that 1024 bytes. Is it? Yeah. So let it be. Now each record size is 100 bytes, which is fixed length and unspanned. So record size, one record, its size is 100 bytes. So this is what given actually. Okay. Then if you create a primary index of key, okay, we will consider these things later. So let it be time being. Now if you see, one record size is 100 bytes, one block size is 1024 bytes. So now how many bytes or how many records you can place in a block actually? Okay. So that is what number of records per block, how you will get actually. So block size 1024 bytes by record size 100 bytes. So that how many records you can place in one block. That is what actually, because and one more thing you have to consider, this is unspanned. So part of the record you should not place actually. So that is why 10 records you can place. Bytes cancelled, and if you take the floor value, then you will get 10 actually. So 10 records you can place in one block. That is what our thing actually. Now you see total how many records we have? 30,000 records we have. That means in one block, if you place 10 records, Then total blocks, how many required? So number of blocks required. Number of blocks required. How many blocks are required? So total records are 30,000 and number of records per block is 10. So 3,000 blocks are required for storing these 30,000 records actually. So that is what one simple thing we have to understand. Okay, so what does it mean actually? So you can see here, suppose this is one block. So in this block, how many records you can place? 1, 2, 3. So like that, 10 records only you can place. So total 10 records you can place. So this is the block number 1. Now like this, how many blocks are required? Total 3,000 blocks are required. So that is what B 3,000 blocks. So this total is 30,000 blocks we are going to place. Total 30,000 blocks we are going to place in this 3,000 blocks actually. 30,000 records we are going to place in this 3,000 blocks. That is what the simple understanding. Now, basing on our previous discussion, if you come back here actually, just a minute. So here, if you see, basing on our this discussion, okay. So here you can see number of index records is equal to number of blocks actually. So that is what you have to apply here. So how many index records are required? So here in this example, you see, suppose index table if you take. So here we have a 2 fields, right? That is what key we discussed, block pointer we discussed. So how many records we are going to have here? How many blocks we have? That many index entries we are going to have. So that is what 3,000 index entries are required actually. So that we can discuss in this way, right? Number of anchor records. Number of anchor records. How many? Per block 1 record. That is what 3,000 anchor records are there. This many index entries are there. Number of index records that you can write down as number of index records. So that is what this discussion, right? Number of index records, how many we are going to have? 3,000 we are going to have. So for each block, 1 record we are placing. So that is what this discussion till now. Okay. Now let us take the remaining things actually. So he given that if you create a primary index, yes, we are applying on this primary index. So key is going to take. So key field is going to take how many bytes? Key field is taking 9 bytes and block pointer is going to take 6 bytes actually. That is what he mentioned. Okay. So that means one index record size is how much? Index record size. So index record is nothing but key and block pointer. So that is what actually 9 plus 6, 15 bytes is required for one index record. So from this, what is our understanding is to store these index records where you are storing actually in the again block only, in one block only we are going to store. So that means how many blocks are required for these index records? That is what number of index records per block, number of index records per block. So that means here you see all 3,000 you cannot place in one block. So this, if you expand, here few, here few, here few, we are going to place. So that is what overall 3,000 anchor records you are placing actually. So that meaning is what actually 1024 is the block size divided by 15 is going to take one index record. So this is going to give us 68 actually. That meaning is 68 index records you can place in one block. Got it or not? So this is what actually. In one block, if you are able to place 68 index records, then total blocks required for 3000 index records actually. So number of index blocks required is equal to total 3000 index records are there. In one block, you can place 68 records. So that is nothing but 45. So that means you can see here, this is first index record block, second index block, third index block, like this. This is 45th index block actually. So all 3000 index records you placed across 45 index blocks actually. All 30,000 records we placed 3000 blocks. This is data blocks. This is index blocks. That must be clear actually. These are index blocks. Make it clear, index blocks. And these are the data blocks actually. So index blocks are required, total 45. So this is the very first thing you have to understand from this whole discussion. So you can see number of records are given 30,000. Block size is 1024, record size is 100 bytes. So in one block, how many records we can place? So from the given that block size is 1024, one record size is 100 bytes. So you are going to place 10 records per block. So if you are able to place 10 records in one block, then total blocks required how many? Total records by number of records per block. That is what 3000 blocks are required for placing your 30,000 records. Now that is nothing but actually this many blocks are there means that many anchor records are there. That many anchor records are there means that many index records are there. So that is what our conclusion from this. Now from this, what we are going to do now, how much key field is 9 bytes given, block pointer size is 6 bytes. That means one index record is 15 bytes. So that is what here 3000 index records are there. One index record size is 15 bytes. That is what we calculated. If one index record taken 15 bytes, then how many index records you can place in one block? That is what 68 actually. So in one block, you can place 68 index records. So total blocks required for placing these 3000 index records is 45 actually. So this is the thing we have to find finally. Now here actually, if you have an index, if you don't have an index, that is what actually the concept now. So because you have an index, this is what total 45 pages. That is what our previous discussion, if you observe this point, number of records is the blocks actually, B actually here. So total access time is how much? So that is what actually, if you take case A, okay. So number of records with index actually. So number of searches, how many searches it is going to take, number of searches required with the index, with the indexing. So that is what actually log 45 base 2. So this is going to give you approximately 6. Now plus 1 you have to do. This is because once we get the index space, to get the data page, we have to make a move from index page to data page. So that is what actually you can see in the diagram also. Total 45 index pages are there. So this log 45 base 2 is giving 6. So at most 6 searches it is going to take. That is, you landed on a exact index page actually, index block. Then once we get the index page. From index page to corresponding data page, you have to go, right? So that we are going to consider as one complex T. So that is the way you can write down +1 here. That is what 7. Okay, so this is what with index actually. So for example, you don't have any primary indexing, nothing actually. So case 2 I am writing here. Case B, what is this? Without indexing. Without indexing. So without indexing, if you observe here, that means this whole part is not there actually. So try to understand simple manner. This whole thing is not there. You have only data blocks. That means 3000 data blocks you have. So 3000 data blocks means in this only you have to search. And of course, data blocks are ordered. Because they are ordered, you can apply binary search. So that is why again here, log 3000 you have to apply base 2. So this is going to take approximately 12 searches. Is it or not? So that is what with the indexing, drastically number of searches are reduced, and without indexing, number of searches are more actually. So this is what one simple question end to end. In between, if it is a competitive exam, they can ask anywhere actually. They can ask a number of index records per block, how many, or number of index blocks, how many required they can ask, or how many searches are required with primary indexing. Anything, anywhere they can ask, or here number of anchor records are how many, or a number of index records are how many. So that is what actually try to understand from this simple diagram, this whole discussion. Okay. Hi. So now let us see the next chapter, that is file organization. So this is also very, very important. We are going to see very important topics in this also. One of the very interesting topic is there, that is B trees and B plus trees. That is actually, we can say, balanced trees. Okay. So overall, what we are going to understand in this is how files we are going to store in the system actually. What are all different mechanisms we are going to use? And for each mechanism, what are the drawbacks, what are the advantages and disadvantages? All these things we are going to understand very clearly one by one. Okay. So that is what. So formally, the first thing is storing the files in a certain order is called the file organization. So that is a simple definition actually. Okay. So now the file structure refers to the format of label and data blocks of any logical control record. So actually, actually we are going to have a data blocks. Okay. So every block we are going to have it with some label actually. So that is what file structure refers to, the format of label and its a data block. Okay. So that by using that, we are going to following certain mechanism to retrieve those files very fastly. This logical logical control system we are going to use actually. So this we will get the clarity as we are moving on actually. So if you see the file structure, how it will be. So database is actually a collection of files. So simply you can say, so if you take a database, so database is nothing but collection of files. So we have to, many files will be there. Now, if you go for the file is actually a sequence of records. So we are going to have set of records in these files actually. So that is what we are going to have a records. And each record is going to have what actually data. So this is what the order we are going to have. So here files, you can say blocks also here. So set of blocks, set of files is also calling as a blocks. We are going to store these files in a set of blocks actually. Okay, so this is what one simple thing. So in these blocks, we are going to have a blocking factor. So the average number of records that can be stored in a block. So this point, we are going to refer at one place. So just remember that average number of records that we are going to store in a block, we are calling as a blocking factor, maximum how much you can store in particular a block. Okay. And the another thing is records in the blocks are stored in through two strategies mainly. The first one is spanned strategy and the another one is unspanned strategy. So in the next lecture, we will see together what is these two actually. We will have to understand these two things first of all, because in many places we are going to refer this one. We particular mechanism storing the files in which strategy by using spanned or unspanned. Okay. That is why in the coming lecture, let us try to understand first of all these two. So this is just introduction about the file organization, that is storing a files by using a certain mechanism we are calling as a file organization. So this whole thing we are doing for retrieving the files very fastly whenever required actually. So that means so you have to search them very fastly, so that you have to return the data, whatever file data you need, that file data you have to return as quickly as possible actually. For that you must follow the some mechanism, that is file organization actually. And if you see the hierarchy, database is collection of files or blocks, and files or blocks is going to have set of records, and each record is going to have a set of data actually. Okay, so this is what overall introduction about the file organization. So let us see in the coming lecture what is spanned strategy and what is unspanned strategy. Hi. So now let us see storage strategies in this lecture actually. So as we seen in the last lecture, two storage strategies are there. One is spanned strategy and another one is unspanned strategy. So this is concept wise very simple. Let us try to understand. In spanned strategy, simple, it allows partial part of the record stored in a block actually. So nothing is there. So partial in a one record, some part of the record you can place in one block and remaining you can place in another block actually. So for example, one record, assume that it is going to take 30 bytes. Okay, simple example. So 30 bytes. Now assume that one block size is 100 bytes. Assume that one block size is 100 bytes. So now what is going to happen is, so this is what one block. Okay. So now what is happening? Record R1 we placed here, which is occupied 30 bytes, and record R2 we placed here, that is also 30 bytes. Record R3 we placed here, that is also 30 bytes. Now how much space is remain here? Only 10 bytes is remain, because one block size, this is one block. Okay, so one block size is 100 bytes, so remaining is 10 bytes. Now what you can do is about R4. In the R4 record, 10 bytes you can place in this block, and remaining 20 bytes we are going to place in the another block actually. So that is what R4 here, remaining 20 bytes. So in this way you are giving connection. So that is what he is saying, partial part of the record we can store in block actually. So here some part of the record is there, here some part of the record is there. So this is very simple actually. So this is block 1 and let us take this is as a block 2. Okay. So what is the advantage of this thing, this kind of storage actually records in a system? So we don't have any memory wastage actually. So this much space also you can utilize properly. But what is the disadvantage is, for some records you have to access two blocks. Is it or not? For accessing R4 record, I have to access two blocks. So it is taking more time actually. And assume that record R4 you are going to access more number of times actually. So in that case, every time two blocks you have to access, so automatically accessing time it is increasing. So that is what disadvantage if you go for the spanned strategy. You are spanning entire block actually. That is simple thing. So this is well suitable for variable length records actually. So whenever you have like this, if assume that in our case, all records length is 30 bytes, fixed length. If it is fixed length, what is going to happen? Definitely, if it is not a multiple of block size is not multiple of this one, definitely part of the record you have to place. If it is variable length, sometimes there may be chance of some records you can fit in this remaining space actually. So that is why it is suitable for the variable length records actually. Now, just quite oppositely for the spanned strategy, unspanned strategy, let us try to observe. In this, no record, we are going to place more than one block. So this is same example. If you take block size is 100 bytes, record length is 30 bytes. So what we are doing in this case is R1 we are placing here. So 30 bytes occupied. R2 we are placing here, of course, 30 bytes occupied. R3 also we are placing here 30 bytes. 10 bytes are remain, that is going to leave as it is. Then R4 we are going to place in the next block actually. So this is what block 1, this is what block 2. So what is happening here? So for every block, you have to access only one block. For every record, you have to access only one block. So very simple thing, right? So that is what unspanned. You are not going to span entire block. So what is the advantage in this way? So oppositely, you can access with a single block actually. Every record you can access with a single block. But a disadvantage is some space you are going to waste actually. Some memory is going to waste. And of course, this is suitable for fixed length records actually. Okay. So this is what actually different storage strategies. These strategies are required. Whatever mechanisms we are going to see in the coming lectures under this file organization. So we will simply say that it is going to use spanned strategy or unspanned strategy. Based on that, try to visualize that how records are going to store in the blocks. Okay. Hi. So now let us see another discussion in this file organization, that is organization of records in a file actually. Okay. This is also understanding wise simple. Just let us try to understand. So here the first one is unordered file organization and another one is ordered file organization. Okay. So it is simple concept. In a unordered file organization, as the name implies, a record can be stored anywhere in the file where there is a place for the record. So you are not following the particular order actually. If you simply find a space somewhere, there we are going to place. So because of this simple statement, what is the advantage actually? So you can insert anywhere actually. Is it or not? So insertion is simple thing. But what is the disadvantage? It is like at a home, you are going to have a set of objects. So wherever space is there, you are going to place that object actually. But the difficulty, so insertion is easy actually. But the difficulty is searching actually. So disadvantage is whenever you are searching for that job, that object, it is going to become very expensive. So it is becoming what actually, it is becoming linear search. So you have to go for the order of n time actually. So that is what in case of unordered file organization. But in case of ordered file organization, you are going to follow a particular order. So all the files are stored in an order of some such key value actually. That is what actually our next discussion. So here you can observe that here search key and its corresponding value is going to be there. So basing on that, you are following some order for storing especially. Okay. So because of that, advantage is searching actually. Searching you can do very efficiently. So because if you follow particular order, ascending order or descending order, basing on the key what you are using, you can implement binary search. If you implement binary search, what is the complexity? You can search anything within log n base 2 time. You can find that element in the worst case. But here, if you are following the linear search, then it will take order of n time. The only difficulty if you follow the ordered file organization is insertion actually. Insertion is expensive because you have to find its corresponding position basing on its key actually. So that adjustments you have to do, a lot of things you have to do whenever you are inserting actually. So that is why ordered or unordered, they have their own advantages and disadvantages actually. Okay. So basing on the thing, whatever, see, even in real time also, if you take the insertion operation, okay, and next one is search operation. See, most of the people will go for the ordered file organization, though insertion is going to take very expensive. Because you see in the real time, insertion you will do one time only. Whenever first time you are inside, whenever first time you are placing that record, you will do insertion actually. But searching you will do many times. So in real time, this is even less than 1% of the time you will do insertion. But searching more than 99% of the times you will do searching only. So only first time you will bear that expensive, but after that it is going to do very efficiently, right, for searching. So that is why it is better, though insertion is expensive. But if you go like this, insertion is simple, but whenever you need that one, it is going to become very expensive. That is what order of n time it is going to take. So this is one way of strategy actually, how records we are going to store in a file. Okay. Hi. So before going to see actual index concepts, so let us try to have a familiar with the two definitions, that is a sparse index and a dense index. Okay. So these are the well familiar words in matrix actually. So let us try to understand in the index also. So this is very simple. What is sparse index? What is dense index? Let us try to understand in simple manner. So in case of sparse index, what is happening is index record appears only for a few items in a data file. So it is very simple. We are going to have a set of data items, data files, but for few data files only, we are going to have a index actually. So that is each item points to a block as shown here. So you can see here with a simple diagram. So to locate a record, we this point, let us just first of all try to understand this diagram. We are going to have a key. This is what the key, you can say index, and it's a block pointer actually where it is located. So you can see the set of blocks here. 1 to 10 is there in this block. 11 to 20 is there in this block, and 21 to 30 this block, and 31 to 40 this block. So these are the blocks we have. So as he mentioned, only for the few data files, we are going to have a record. So that is what here for this block, for one, we have a index. That is what you can see. So that is what pointing to this one actually. And then for the 11, we have a block pointer. And then for the 21, we have a block pointer in this record. And for the remaining records, we don't have a block pointer. That is what you have to understand from this. And then for 31, you have a block pointer here. So that is what, wherever sparse index is there, or for the meaning of sparse, we are not going to have a index for all the records in the file actually. Only for the few you are going to have, that too it is pointing like this. Okay. Now, if you want to locate any particular key, so that is what, to locate a record, we find the index record with the largest such key value less than or equal to such key value we are looking for. If I am searching for a 9, so you can see 1 here and 11 here. So because this is starting from 11 and this is starting from 1, in between these two, I can confirm that my record is going to exist through this block pointer. That is what this line is saying. So largest value less than or equal to such key actually. If I am looking for a 15, this is largest value. So before record is going to have 15 actually. So in this way, I'm going to come. So this is what the sparse index actually. Always basing on this range, you can decide in which block you are going to have your record. And main thing is for all records, you are not going to have a index actually. But when you come to the dense index, quite opposite to this, that is a record is created for every such key valued in the database. So you can say simply for every record in the block, we are going to have an index actually. So that is what this help you to search faster, but needs more space for storing index records. Here you can see totally 40 records are there. So only 4 index records we have. But here, how many records we have, that many index records we need actually. So that is what diagram wise you can understand. So here you can see total 8 records are there. So 8 index records we need. Is it or not? So that is what simple thing, and they are going to point like this. Only keys are ordered, and these may be ordered or may not ordered. So that is what this help you to search faster, but needs more space to store the index records. This is what this table required more space actually. In this indexing, method records containing search key value and points real record on the disk. So whichever key you need, suppose I need 40. So directly it is pointing 40. That is what this point is mentioning. But here it is not like that actually. Here for which record you are searching, that record directly you can go actually. But here directly you are not going. If I am searching for the 5, I am not going directly to the 5 actually. First I need to come 1 and then I will go to the 5. So that is what actually sparse index and the dense index. So simply in the sparse index, for every record we are not going to have an index record, but in the dense index, for every record in the database you are going to have an index record, so that accessing is very fast. Okay. Hi. So now we are going to see actual concept in this file organization. That is what actually indexing. So you see, before going to see what is this indexing concept, this is not a new word actually for us. Definitely this word is well familiar since our childhood actually. So if you take any textbook, simple understanding first of all, if you take any textbook, in the textbook, we are going to have a set of chapters. So each chapter is going to exist in a particular page number. Okay, and chapters, sub-chapters, different things are going to be there. In the every chapter, we are going to have set of topics. So what we will do is, in every textbook, initially, if you see in the initial pages, you will find the index. So in the index, what we are going to have chapter number, chapter name, and in which page that is there actually, that page number we are going to have. So you just keep that in mind while you are discussing, when you are listening this chapter especially, okay, this indexing concept. So nothing is there in this. So in a textbook, how we are going to have an index in the initial pages, so that if you need any particular chapter, you will simply refer that index, and then where is that chapter, you will identify that page number, and directly you are going to but that page number. Instead of searching in every page, first we are referring in the index, then we are finding where that chapter is there and its page number, then we are going directly to that page number actually. So exactly same concept we are going to understand from the file organization. That is indexing. So ultimately what that index making you what actually? This is what it is doing ultimately. Indexing is a data structure technique which allows you to quickly retrieve records from the database file. So just relate this one with our textbook example. So if you want to go to particular chapter, because of the index, we are able to retrieve very quickly, right? So that is what, even here also, if you want to record, if you want to retrieve the records or blocks or files very quickly, index is going to help you actually. So if this index is a one kind of data structure you are following. That's it. So this is what, that is why I told you that you just remember the textbook example. Exactly same manner we are going to, throughout our discussion, same thing we will refer for better understanding logically. Okay. So then next, if you see an index is a small table having a 2 columns. So this also you can relate with our example actually. So that is the first one is first column comprise a copy of the primary key or candidate key of the table. Okay, search key, whatever, with what you will search. So for example, DBMS textbook, if you take, I want normalization. That is what my search key actually. Is it or not? That is what my, see, normalization is going to exist in the index only one time. So that is what, that is the candidate key or the primary key for me. So in which page number that is there, I have to find. So for that, first of all, you need a first column, that is the search key. Then the second column is actually the important one. Second column is actually a pointer. So where that disk block is existed. So it is simply like a page number. So normalization chapter, in which page onwards it is started. That page number is nothing but a disk block actually. So this search key, in which disk it is presented, that is given by this pointer actually. So for example, I am searching for the normalization. So normalization chapter, I want to find where it is in the textbook. then we are going to have a page number like this, right? That is the simple understanding. Nothing is there here. So that page number, that means from that block, in that block, you have this chapter actually. So wherever that search key in which block it is there, that is pointed by these pointers. That is, you can say, actually called as a block pointer. So if you see that diagram, we are going to have a search key, and this is the block pointer actually. So in this way, we are going to have a one index. In the index, one record we are going to have like this. It's a search key corresponding block pointer. In which page number, simply you can say that is nothing but address only finally. Okay, in the disk, in which address it is there. Okay, so that is what actually this concept only we are going to see overallly. Okay, now this index, how you are organizing, how you are maintaining actually, what are different strategies we are following. So that is what the simple thing. So this index we are going to mainly maintaining in two ways. That one is single level index and another one is multi-level index. Overall, we are going to see this only. So that is, in the single level index, again, you have three types. One is primary index, clustered index, and the secondary index. So everything we are going to see separately. And in the multi-level index, we are going to have B trees and B plus trees. So very, very important is B trees and B plus trees. You might heard these words in many places. So that is actually B for balanced trees actually. So of course, we will see everything clearly. Okay. So in the coming lectures, actually, we are going to discuss all these five separately. Primary index meaning is what, how it is maintaining, clustered index, how it is maintaining, and secondary index from the single level index. And in the multi-level index, B and B plus trees we are going to see actually. So this is what overall what we are going to see in this chapter. From this lecture, you must get the idea actually. Okay. Hi. So now let us see in the single level indexing, the first one, that is primary indexing. Okay. So understanding primary indexing is very simple. So let us try to understand in simple manner. So here, what is primary indexing? You can see in the primary indexing, it is a ordered file, which is fixed length of two fields actually, very importantly. The first field is primary key and the second field is block pointer pointing to the specified data block actually. So this exactly, if you see the graphical representation, so this is what actually he told. Primary key field is this one and block pointer is this one. That is what fixed length two fields. The first field is primary key, this one, and the second one is block pointer, which is pointing to the blocks actually. So that is what you can see the blocks here. So there are total 3 blocks are there, for example here. So these 3 blocks, how they are going to connect to this indexing table actually. So that is what you can see, an index entry. So here how you will make an entry is created for the first record of each block. So if you see this red colored record for every block, that is calling as a block pointer. So an index record is created for the first block, first record of each block. So here you can see first record is 1. For that we are going to create a record, and this second B2 block, first record is 5. For that you created an index record, and for B3 first record is 9. For that we created an index actually. So that is what actually. So in every block, first record we are calling as a block anchor. So how many blocks we have, that many block anchors will be there. That is what the first record. That we are going to, for that we are going to create a index entry actually. So then the number of index records. So here how many index records we are going to have, that many blocks we are going to have actually, that many data blocks we are going to have here. So all these are the data blocks. So how many index entries? So number of index entries. Number of index entries. How many will be there? Number of blocks. That's it. So 3 blocks are there. 3 index records are there here actually. That is what this meaning. And this type of is called actually sparse index actually. So you can see, as we discussed in the last lecture, what is meaning of sparse index? So the sparse index is for every record we are not creating an index. Only for the few records we are creating an index. That is nothing but a sparse index, right? So whenever you have, and one more thing, so here both the data pages and index pages are ordered. So you can see this data is ordered and this data is also ordered in the data pages. So that is another thing actually. Now, very importantly, in the primary index, the average number of block accesses is log b plus 1 actually. So b is the number of blocks here. So why it is log b? Because it is a sparse index we are using. That meaning is index pages are ordered. So you can apply binary search actually. So since you can apply the binary search, it is going to take log b base 2 time. And from there, from here to here, it is going to take one more extra access. That is what total access time actually. On an average, this much time it is going to take. So this is what overall primary indexing. So very simple that we are going to have a set of records in every block. Okay, fine. And we are going to have a index table. So this is the index table. Index table have 2 fields, primary index and block pointer. Then for every block, for the first record, we are creating one index entry. So that is why in every block, first record we are calling as a block anchor. So for every block anchor, one index entry we are creating. So simply you can say how many block anchors are there, that many index entries are there actually. So for this, because elements are ordered in the primary key, so it is going to take log b base 2 time. So overall it is going to take this much time for access actually. So this is called primary index. So for the better understanding in the next lecture, let us see one simple problem for understanding of whole discussion actually. Hi. So now let us see one simple problem under primary index actually. So for better understanding of this concept. So let us see first of all, what is the question here? Consider a file of 30,000 records actually. So total records, how many we have? So total records are 30,000. Let us make a note. Yeah. And then stored in a disk with block size 1024 bytes actually. So this is meaning is what? Block size given that 1024 bytes. Is it? Yeah. So let it be. Now each record size is 100 bytes, which is fixed length and unspanned. So record size, one record, its size is 100 bytes. So this is what given actually. Okay. Then if you create a primary index of key, okay, we will consider these things later. So let it be time being. Now if you see, one record size is 100 bytes, one block size is 1024 bytes. So now how many bytes or how many records you can place in a block actually? Okay. So that is what number of records per block, number of records per block. How you will get actually? So block size 1024 bytes by record size 100 bytes. So that how many records you can place in one block? That is what actually, because and one more thing you have to consider, this is unspanned. So part of the record you should not place actually. So that is why 10 records you can place. Bytes cancelled, and if you take the floor value, then you will get 10 actually. So 10 records you can place in one block. That is what our thing actually. Now you see total how many records we have? 30,000 records we have. That means in one block, if you place 10 records, then total blocks how many required? So number of blocks required. Number of blocks required. How many blocks are required? So total records are 30,000 and number of records per block is 10. So 3,000 blocks are required for storing these 30,000 records actually. So that is what one simple thing we have to understand. Okay, so what does it mean actually? So you can see here, suppose this is one block. So in this block, how many records you can place? 1, 2, 3. So like that, 10 records only you can place. So total 10 records you can place. So this is the block number 1. Now like this, how many blocks are required? Total 3,000 blocks are required. So that is what B 3,000 blocks. So this total is 30,000 blocks we are going to place. Total 30,000 blocks we are going to place in this 3,000 blocks actually. 30,000 records we are going to place in this 3,000 blocks. That is what the simple understanding. Now, basing on our previous discussion, if you come back here actually, just a minute. So here, if you see, basing on our this discussion, okay. So here you can see number of index records is equal to number of blocks actually. So that is what you have to apply here. So how many index records are required? So here in this example, you see, suppose index table if you take. So here we have two fields, right? That is what key we discussed, block pointer we discussed. So how many records we are going to have here? How many blocks we have? That many index entries we are going to have. So that is what 3,000 index entries are required actually. So that we can discuss in this way, right? Number of anchor records. Number of anchor records. How many? Per block, one record. That is what 3,000 anchor records are there. This many index entries are there. Number of index records that you can write down as number of index records. So that is what this discussion, right? Number of index records, how many we are going to have? 3,000 we are going to have. So for each block, one record we are placing. So that is what this discussion till now. Okay. Now let us take the remaining things actually. So he given that if you create a primary index, yes, we are applying on this primary index. So key is going to take. So key field is going to take how many bytes? Key field is taking 9 bytes and block pointer is going to take 6 bytes actually. That is what he mentioned. Okay. So that means one index record size is how much? Index record size. So index record is nothing but key and block pointer. So that is what actually 9 plus 6, 15 bytes is required for one index record. So from this, what is our understanding is to store these index records where you are storing actually in the again block only, in one block only we are going to store. So that means how many blocks are required for these index records? That is what number of index records per block, number of index records per block. So that means here you see all 3,000 you cannot place in one block. So this, if you expand, here few, we are going to place. So that is what overall 3000 anchor records you are placing actually. So that meaning is what actually 1024 is the block size divided by 15 is going to take one index record. So this is going to give us 68 actually. That meaning is 68 index records you can place in one block. Got it or not? So this is what actually. In one block, if you are able to place 68 index records, then total blocks required for 3000 index records actually. So number of index blocks required is equal to total 3000 index records are there. In one block, you can place 68 records. So that is nothing but 45. So that means you can see here, this is first index record block, second index block, third index block, like this. This is 45th index block actually. So all 3000 index records you placed across 45 index blocks actually. All 30,000 records we placed 3000 blocks. This is data blocks. This is index blocks. That must be clear actually. These are index blocks. Make it clear, index blocks. And these are the data blocks actually. So index blocks are required, total 45. So this is the very first thing you have to understand from this whole discussion. So you can see number of records are given 30,000. Block size is 1024, record size is 100 bytes. So in one block, how many records we can place? So from the given that block size is 1024, one record size is 100 bytes. So you are going to place 10 records per block. So if you are able to place 10 records in one block, then total blocks required how many? Total records by number of records per block. That is what 3000 blocks are required for placing your 30,000 records. Now that is nothing but actually this many blocks are there means that many anchor records are there. That many anchor records are there means that many index records are there. So that is what our conclusion from this. Now from this, what we are going to do now, how much key field is 9 bytes given, block pointer size is 6 bytes. That means one index record is 15 bytes. So that is what here 3000 index records are there. One index record size is 15 bytes. That is what we calculated. If one index record taken 15 bytes, then how many index records you can place in one block? That is what 68 actually. So in one block, you can place 68 index records. So total blocks required for placing these 3000 index records is 45 actually. So this is the thing we have to find finally. Now here actually, if you have an index, if you don't have an index, that is what actually the concept now. So because you have an index, this is what total 45 pages. That is what our previous discussion, if you observe this point, number of records is the blocks actually, B actually here. So total access time is how much? So that is what actually, if you take case A, okay. So number of records with index actually. So number of searches, how many searches it is going to take, number of searches required with the index, with the indexing. So that is what actually log 45 base 2. So this is going to give you approximately 6. Now plus 1 you have to do. This is because once we get the index space, to get the data page, we have to make a move from index page to data page. So that is what actually you can see in the diagram also. Total 45 index pages are there. So this log 45 base 2 is giving 6. So at most 6 searches it is going to take. That is, you landed on a exact index page actually, index block. Then once we get the index page, from index page to corresponding data page, you have to go, right? So that we are going to consider as one complex T. So that is the way you can write down +1 here. That is what 7. Okay, so this is what with index actually. So for example, you don't have any primary indexing, nothing actually. So case 2 I am writing here. Case B, what is this? Without indexing. Without indexing. So without indexing, if you observe here, that means this whole part is not there actually. So try to understand simple manner. This whole thing is not there. You have only data blocks. That means 3000 data blocks you have. So 3000 data blocks means in this only you have to search. And of course, data blocks are ordered. Because they are ordered, you can apply binary search. So that is why again here, log 3000 you have to apply base 2. So this is going to take approximately 12 searches. Is it or not? So that is what with the indexing, drastically number of searches are reduced, and without indexing, number of searches are more actually. So this is what one simple question end to end. In between, if it is a competitive exam, they can ask anywhere actually. They can ask a number of index records per block, how many, or number of index blocks, how many required they can ask, or how many searches are required with primary indexing. Anything, anywhere they can ask, or here number of anchor records are how many, or a number of index records are how many. So that is what actually try to understand from this simple diagram, this whole discussion. Okay. Hi. So now let us see the next indexing, that is cluster indexing. So this is also very simple if you compare to the previous one actually. So that is here if you see the cluster index is an ordered file which is fixed length size of 2 fields of course. So the first field is an actually non-key and the second field actually block pointer pointing to a specific data block actually. To get the first of all idea how cluster index is, it is actually if you see index page like this, then it is created on a cluster. That is what group of values actually column of a table. So how and all, let us see here. Suppose this is one cluster actually. See group of values, same value actually. So which are all have the same value, that is going to take as a one cluster. So next cluster is this one and the next cluster is this one. So then we are going to point like this. So for every cluster, one index record we are going to create. That is what simple understanding. An index record is created for each distinct value of a non-key. Simply you can say. So what you can say, the number of index records are number of clusters. So you can say both data pages and of course index pages are ordered. The very important thing is the number of index records. How many index records here we are going to have, that many clusters we are going to have here. And of course, there should be only one clustered index per table. That is what our discussion. And of course, this is also an example for the sparse index. Okay. This is what actually clustered indexing actually. This is very simple. For each one cluster, one index record we are simply creating. If one group of values, one value, if it is more than size of a one block, then another block we are creating, and in that block we are going to store those values. And this block, last one is pointing the another block actually. In this way, clusters we are going to maintain. So that is what, if any one value more than one block, then we are going to arrange them like this actually. So this is what actually cluster index, which is very simple one. Hi. So now let us try to understand secondary index. This is somewhat logical actually. So of course it is very simple if you understand primary indexing and cluster indexing. So here actually why this name is called secondary index. So first of all, secondary index is created other than primary key and cluster column actually. So that means we are not creating indexing on the primary key actually. So other than primary key and non-key on non-key we are going to create actually. So how can I understand this one? So let us take actually, of course, this is one simple point, important point actually, for the secondary index. Index entry is created for each record of the data file. So this point, let it be. So now we'll come back to that. So if you take the data blocks, so these are the data blocks assume. So this is the, for example, employee table, this is the employee number. Okay. And this is the, for example, PON number. Okay. So that is what the PON number we have here, for example. So we are not creating the index on this primary key actually. We are creating an other than primary key on some other key actually we are going to create. So secondary index may be on candidate key or non-key. It is the file is unordered. This is not ordered actually. That is what very, very important thing. On which you are creating indexing, that is not ordered actually, that is unordered. So if you collect the employee numbers, every employee's PAN number, that need not be ordered, right, as per their employee number. Okay, so that is why this is unordered. On this, you are going to create a indexing actually. So that is called actually the secondary index. You are not directly creating on the primary key. On a candidate key or some other non-key attribute, you are going to create a indexing. So how and all, let us see here. So this is what the key and block pointer as usually. So as we told this PAN number, on this PAN number, we are going to create a indexing. But in the blocks, in the data blocks, they may not be ordered, but in the index blocks, they are ordered actually. That you can observe actually 12, 15, 23, 24. All these numbers are ordered. That is very, very important. You have to understand. And as we told this point, index entry is created for each record. So this is one record. This is one record. Total 12 records are there, for example, in this example. Now 12 records we have in the data blocks. Now 12 records are there in the index blocks also. So in this way we are going to create. Now for the 12, you are going to create a pointer like this. So where is the 12 actually? Here it is there. So 12 pointing like this. That is what the block pointer, that means address of this you are storing it here. So like this, 15 is stored at this third block. You can see here 15. So like that you can see 23, 24, 29, 34, 36, 40, 54, 64, 67 and 69. So very, very important thing, you have to understand why this name came. Secondary index, first thing is you are not creating on a primary key. Some other key in the table you are going to create, that may be a candidate key or some other non-key attribute that may be. And in the data blocks, these are all the data blocks, right? So the data blocks need not be ordered, that whatever key you selected, whatever attribute you selected. But in the index blocks, these are the index blocks. So in the index blocks, on which attribute you created a indexing, that data definitely ordered actually. So this is what actually secondary index in simple manner you can understand. So every very important thing is an index is created, an index entry is created for each record actually. So what you can say, the number of index records is equal to number of records of data actually. How many records are there in the data blocks? That many index entries are there in the index blocks actually. That is what simple understanding. That is very important also for the numerical problems. If you are using secondary index. That is what this kind of things is calling as a dense index. That is why we discussed already sparse index and dense index. In the dense index, you are going to create a record for every record in the data block actually. Okay. So this is what actually, Hi. So now let us see the same problem which we've seen in the primary indexing. In the secondary indexing, how things are going to change, let us observe actually. So as usually, so total records given that number of records is actually 30,000. So let us take 30,000. Okay. Then of course, block size is, so let us take quickly whatever is given. So block size is 1024 bytes. And record size is, one record size is 100 bytes. So that is 100 bytes. Okay. So now from this actually, as we know that number of records are 30,000, because it is a secondary index, how many records are there? That many index records we are going to create actually. So that is what very important thing is, number of index records, how many we are creating? Number of index records, how many actually? 30,000 we are going to create. Is it or not? Then, so from this actually, as they given actually, key size is in the index actually, in the index record, key size is 9 bytes and block pointer size. So block pointer size is 6 bytes. So the same values actually 6 bytes. So that means actually index record size is what actually? Index record size. One index record size is how much? 9 plus 6, 15 bytes. So same thing till now actually. Now, even here also, number of index records per block, how many? So that is what number of index records, per block. So that is what block size 1024 bytes by record size, index record size 15 bytes. That is actually we already calculated earlier. That is 68 index records you can place in one block. Is it or not? So now how many index blocks are required for this 30,000 index records? That is what actually. So that is number of index blocks. Number of index blocks, how many required? Index blocks required. So total we have 30,000 records are there, and in one block you can place 68 records actually. So this is actually almost 450 blocks are required actually for this 30,000 index records. Is it or not? So this is what actually going to happen. Now, for example, case A, without any index, if you use the secondary indexing actually, without index, what we are going to do, because these are unordered, that is very important. If it is secondary index and without indexing actually, without index, if you use, what is going to happen? Linear search you are going to apply on average 1500 searches are going to required actually. Now case B, that is what actually with secondary indexing. So with the secondary indexing, that is what with secondary indexing, what is going to happen? Log 450, because these are ordered, right? You taken in the ordered form in the indexing actually. So that is what you can see here. So here, though here part number is not ordered in the data block, but in the index blocks, these are the ordered actually. So that is why you can apply log 450 base 2. So you are going to get approximately 9. And for this 9 plus 1 for the data block, 9 searches required in the index blocks. And one search is for actually from the index block to data block. That is what total 10 searches are required. Within 10 searches, you can reach actually the actual record. Okay. So this is what average number of blocking access, an average number of blocks accessing required is 10 actually. So this is what the difference to previous primary indexing and secondary indexing actually. So question is same, but number of blocks accessing is different actually. Okay.